My name is Brian Vandeven, and I work with Jean-Luc at Continuum on the Bokeh project, and Jean-Luc, of course, works on HoloViews. Just wanted to say a few quick words, then really going to turn everything over to him. As mentioned already, unfortunately, Philip Rudiger cannot be here today, but we'll try to take it easy on Jean-Luc, and I'll be around to try to help folks if they have any questions. And of course, Jim Bednar is also on the Slack channel. I encourage everyone to go there for any help as well. I just wanted to say, I'm really excited about HoloViews. Been working on Bokeh the last several years, and one of the things we've wanted to do is have a really accessible, high-level interface for people to do exploratory type data analysis just as quickly and as simply as possible. And I'm really pleased to say that HoloViews has definitely filled that role. So I just want to make a clear statement about bokeh.charts. Going forward, the endorsed sort of recommended high-level API on top of Bokeh is going to be HoloViews. And so I think you'll see today that it's really fantastic, has a lot of capability. It's already actually well beyond, I think, whatever bokeh.charts used to do already. And I think you'll find that it's a very pleasing API to use as well. So I think with that, I will turn it over to, oh, sorry. I also want to mention we have some stickers on the end of the table. We have some GeoViews, HoloViews, and data shader stickers. You'll see all of those things today. And with that, I will turn things over to Jean-Luc. And just raise your hand or anything if you have a question. I'll come try to take a look.
First of all, thank you all for being here. I guess we'll just dive straight into it and try and get everyone set up, make sure everyone's got their laptops working correctly. Yes? Oh, sorry, this is the Slack. Oh, I think it's an invite you need. You should have received an invite to join the Slack channel. You should check your email. I think that's how everyone got there. Yeah. Okay, so what I'll do is I'll just say a few things that you could do just to get things set up, and then I'll introduce it with the introduction notebook. Firstly, has everyone managed to clone the Git repo? If you haven't, put your hand up. Okay, great. It seems like everyone's managed to do it. And I hope everyone's managed to do the Conda environment YAML to set up the Conda environment. Is that true? Everyone's managed to make the HV tutorial environment. Is that right? If you haven't, could you put your hand up? Okay, so there's one. Let's help. Yes, so, right, that's exactly right. So everyone who's got a Git repo and the HV tutorial environment, please just git pull. One git pull in the repo, and then conda env create. You can see it on the screen here. Sorry, that's not right. Yes, so the line that I've highlighted on the screen is the thing to run after you run git pull. So run git pull, run that. It really doesn't, it's not going to pull in much. It's just HoloViews 1.8.1 was released on Friday. It's got a few bug fixes. It'd just be more pleasant if all works for everyone. Right, yeah. Okay. Also, if there are questions like that, do go on the Slack channel, and there's both Chris Ball and James Bednar will be able to help you. So that's, I think it's Jay Bednar and C Ball. They'll be able to help you on the Slack channel. So in that case, I'm going to hope that everyone's been able to run that. It should be quick, and then I'll start introducing the talk now, and the tutorial. So, right, and I suppose I should also say that once you've actually got that done, okay, I guess I'll just ask again. How many people managed to run the update command? Okay, good. That's good. Who hasn't? Who's still waiting on that? Okay, that's great. In that case, do cd into the notebooks directory, and then run Jupyter Notebook with this command here. Hopefully, in a few seconds, everyone will have Notebook running. Yes, so this parameter is essentially to get around a limit, a limiting value that Jupyter Notebook now has in terms of how much data you can push at a time. This just increases the limit to something large so that you can actually push large data to the notebook. I understand that in the next notebook version you won't need this, so it's a temporary thing, in case you haven't seen that before. Okay. I don't, so you're running on Windows? Does it not accept it? You can try it and see if it works. I hope so. Okay, so great. So once you've done that, you should be able to go to the notebook page and just click on the welcome, 00 welcome notebook, and then hopefully you'll be seeing what I'm looking at now, what you see on the screens. And the last thing I should mention is if you have any trouble, if you go to the repo, you can go to notebooks, and there's also now a list of these notebooks with the output in them available on MBViewer. So that's in case you're not able to run things live, which hopefully won't happen, but it's there as a backup. Okay, great. So anyone not able to run the notebook right now? Okay, fantastic, great. So this is the HoloViews and Bokeh tutorial, and Brian nicely introduced that. I'll be talking about how you can use HoloViews together with Bokeh to make some really interesting interactive applications and dashboards. The thing you're looking at here, this GIF, is an example of what we're going to be working towards in this tutorial. You can see that you've got mouse interaction where you can hover, and you can get cross-section of some really large data sets. This is actually rendered in Data Shader. So this is the very large taxi data set that hopefully people managed to download. And if you haven't, we've got a USB stick that we'll be able to pass around in the break. So that's where we're aiming. And you can also see that there's a little widget at the bottom, which is a Bokeh widget, which you can use to press play and scrub through a time series and that kind of thing. Okay, so I'll quickly go through the schedule. I would recommend everyone do please run through this notebook from top to bottom, because at the end there's a little bit of config, which is just, it's optional, but it helps things, makes things a bit smoother. It just adds a little HoloViews RC file to your home directory. If you don't have one, you can delete it off the tutorial if you don't want it there. So hopefully you can all do that. It also runs the imports that we'll be using, so make sure everything's running correctly. Okay, so hopefully I'll now be able to start talking about the schedule. Well, I'll be starting with something called introducing the HoloViews primitives, which are called elements. These are the basic classes that you use in HoloViews that have a representation that's a rich representation that is rendered, and it can be rendered with different plotting extensions, but we'll be using Bokeh. I'll be introducing these elements as a way of taking your data, putting them in something that has a visual representation, but where you're actually spending your time worrying about how to annotate your data with really important semantic information. You're not really worried about line widths and line styles and colors and things and these kind of aesthetic choices. It's all about what your data means. It's a semantic content. So we're talking about that. That should be about 40 minutes. And it looks like we're all set up, so we seem to be good. Next, I'll be talking about how you can actually take those elements and make them look the way you actually want without actually putting all that information into the elements themselves. This is the HoloViews option system. And I'll also talk a little bit about changing the rendering, the plotting extension, and a little bit about exporting files from your element. So the third section is about containers. So these are the things that contain elements, and you'll see that they'll let you explore really large parameter spaces really easily. And this is how you can actually look at your data, get an intuition for what's going on, and really understand your data visually. So then we'll have a 15-minute break, and then we're going to go and look at some real data sets. We have them in the repo. There's two data sets. One's an economic data set. Got information about countries, GDP, statistics, that kind of thing. It's tabular data. It's in Pandas. And then following that, we're going to look at a very similar tutorial, but looking at array data. So this is going to be MRI data, and it's using Xarray. Quickly, how many people have heard of Xarray or use Xarray? Okay, that's okay, good. So it might be new for quite a lot of people, but that'll be interesting to see. Then, before the 5-minute break, we'll talk about the custom interactivity. So how you can make HoloViews respond to events. That should be really quick, and that will be showing you some stuff that's really Bokeh specific. And you'll see that in a minute. And then after the break, we'll have a data shader section, which is a large data section, and then finally we'll go to that dashboard and we'll deploy the app that you see as this GIF up here. So, okay, so let's just click on the introduction and get this notebook going. Hopefully everyone can do that. I guess before I keep going, I should ask a few questions. How many people are using Python 3? Okay, great, almost everyone. So nothing we have here is Python 3 specific. Everything would work on Python 2, but the environment you have is Python 3. So there shouldn't be anything unfamiliar if you're only familiar with Python 2. Second question, has everyone used notebooks before? Who hasn't used notebooks before? Okay, nobody, great. How many people are using Bokeh? Okay, good number of people using Bokeh, great. And finally, how many people are using Bokeh in the notebook? Okay, a couple people. Okay, so this is going to show you really how you can use HoloViews to really use Bokeh in the notebook in a really powerful way. So the first thing I'm going to do is run the first cell here. Hopefully everyone can do that. Should get this little icon, the HoloViews icon, and then Bokeh icon next to it. Is anyone not seeing that? Okay, a couple of people not seeing that. Okay, you can tell me what you're seeing wrong, and maybe you can go to the Slack channel and ask there if it's something that can fix. Where's Brian? Okay, so what's the problem? Are you seeing an error? Okay, so you might have HoloViews 1.8. Earlier there was the conda update end command to get 1.8.1. It doesn't really matter. You don't have to do that. You might see things very slightly different, but you can probably follow the tutorial just fine. Is that the case for everyone else? So who's got the two little logos? Okay, looks like a good number of people. And who doesn't? Okay, 1, okay, 2, 3. Okay. But do you see just one logo? Okay, great. Fantastic. Okay, in that case, you need to go on the Slack channel and talk to Jim. He'll help you get your environment working with that. Okay, great. So looks like everyone's following so far. So we've just done the standard imports. NumPy we've imported as NP, Pandas we've imported as PD, and HoloViews we recommend you import it as HV. It's just a short qualified namespace name for it. The thing underneath is the extension, and that's where you basically telling the notebook we're going to be using Bokeh to render our HoloViews objects. And that's why you get the two little logos next to each other. So, Brian, you can help the people here having some issues. Yep. Great. Okay, so now what are elements? Well, elements are essentially little containers for your data. They're there to represent your data, and they're not there to talk about things about their visual appearance. They're meant to be what you actually work with. And they happen to have very nice, rich, visual properties. You can actually see a rich representation of them. But really, you have to think of them as your data. And you're basically working on HoloViews to annotate your data with extra information so that your visualization is actually reflecting important things about your data. One thing I'd recommend is everyone should just maybe open up holoviews.org and look at the reference gallery. This will give you a nice sort of layout of all the different element types. And this will give you a little bit of an idea of what we offer in terms of elements currently, and you can start thinking about what can be done with these elements. So you'll come back to that. We'll be looking at various ones of these throughout the tutorial, and we'll just start with a very simple one for now. So, okay, so let's start off with a very simple curve element. So I've run this, and hopefully everyone can see a little inverted parabola. Hopefully that's all good. So essentially what we're looking at is we've got two Python literals, which are lists, one of x values and one of y values. And what we do is we pass these two literal lists into this h3.curve. And h3.curve is an example of one of these elements, right? And we grab a handle on it called simple curve, and then we allow the IPython display machinery to call HoloViews to display it in the cell. So this is rendered with Bokeh, as you can see by the little logo. You can zoom in. You can use all the Bokeh tools. You can pan, you can box zoom, and so on. So this is the representation of our curve object. Most elements, almost all the elements we're going to be talking about in this tutorial, have one positional argument. This is where you pass your data in, and it's mandatory. We do have multiple different formats that we accept. This is just one simple example that just takes lists. But as you will see later on, we can take other things like X-array arrays, Pandas data frames, and other formats too. So has everyone been able to get the curve? Anyone not been able to get it? Who's not already been? Okay, that's one question. Oh, so okay. So maybe best you just ask in the Slack channel, and we'll come back to you in a second. Okay, so now what we have is our curve, and this is holding these two lists. And what we can do is we can look at what happens when you print simple curve. Now we see that the textual representation. So this is the sort of thing you would see in a standard Python prompt where you don't have a rich display. And this is also what you'd see if you ran the notebook without loading that extension at the beginning, right? So this is the simple text representation of this object, which has this representation of a parabola, which you can actually look at, right? So this is sort of the first mini little exercise. It shouldn't take long at all. Just have a look at the .data attribute of simple curve. So you can see it here commented, just uncomment it and run that cell and see what you get. think there's a few more questions over there. That's fine. Okay. Okay, so hopefully, okay. So hopefully you managed to do this and you can see a Pandas data frame. So you pass in the lists and now you have a data frame. Now, sometimes this has happened in HoloViews where you have one format and we put it into another format, but we always preserve your data. These are the same values. We've not lost any precision, we've not lost any information about what those values were, we've simply cast it into a slightly different format. Now, hopefully everyone's seeing a data frame as opposed to, for example, a NumPy array, and that should be the case as long as you have Pandas installed. And the important thing to note is that if you took this data frame and stuck it in the element directly, then it would be completely unchanged. This data frame would be your data in the element, completely untouched by what HoloViews is doing. Okay, so now what we have is a few links to some elements which are just like Curve. They're very similar, they take the same kind of constructor, but they have slightly different visual representations. So we can see them here. We've got Curve, which we've already looked at, area and scatter. So in the first exercise, well, the second exercise now, just try going back here and changing the HV.curve to an HV.area or an HV.scatter. Hopefully, give you a few seconds to do that, you'll see something different. Okay, so I'm going to now actually do one of these. Let's look at, it's now misnamed, of course, because we called it simple curve. I've just taken the cell, changed an area, and this is what you get. Okay. And now you can try it for scatter. And that's what it looks like when you do a HV.scatter. So hopefully everyone's been able to follow me so far. Is anyone still having trouble? Maybe we can have some help. Yeah. Okay. So I suggest we basically, if you have trouble, maybe Brian will be able to help you out when he's available. So, and then also I'll be able to help you in the break. So see how it goes. Okay. Finally, I'm going to just go back to a curve so that it's not a misnamed handle. So what we've seen is 3 different elements, and when you go to the gallery page on the holoviews.org, you will see a whole slew of different elements, which you can pick that have the representation of your data that you want. Right. So we've seen that this is an object, and we've seen the nature of the data. Now, the optional attribute is just look at the dot data of the one you created. So when you switch it to area, look at the dot data. When you switch it to scatter, look at the dot data. Okay, what you'll find is probably what you'd expect. It is exactly the same thing as you saw for the curve. So it's just another Pandas data frame with the same values. Really, nothing should be very different. Okay. So hopefully everyone's following okay. Right. Okay, so this is the simplest way to construct a curve, an area, a scatter. Let's start actually adding some information that's actually more informative about our data than what we've done so far. We just have a sort of raw list of X values and Y values, and we don't know what it is. What does it represent? What's the data really about? Let's give it some metadata to actually say what we're actually talking about. So let's just say that, in fact, our parabola is actually a ball thrown in the air. It's a trajectory. Where you've taken a ball, you've thrown it in the air, and your actual x-axis is really distance, horizontal distance, and your y-axis is the height. So what you can see is we've done 2 things here. We've declared something called key dimensions, which is here's k-dims, and v-dims, which are value dimensions. Basically, they correspond very similarly to sort of independent variables and dependent variables. K-dims are the things you index by, and the thing that you get when you index, those are the value dimensions. So those are the v-dims. So we've just given 2 little strings here, and what you can see is that these have been reflected in the rich visual representation of our object in the axis labels. We now have an actual distance axis and a height axis for y, right? Okay, and I think I'll slow down a little bit. Okay, Now let's actually look at one of these properties, in fact. Right, so let's look at the VDEMs. So what you can see is you gave it as a string, but it's been promoted to a dimension object. And this is a rich object we're going to be using quite a lot. It contains a lot of information about the dimensions, and you'll see this in a minute, things like units, ranges, things like this. But what you see is that the name of the dimension is height, and that's for the VDEMs, and it's in this list because you can have, some elements will have multiple VDEMs. If you look at KDEMs, it's distance. So this is the information you supplied. Yeah. You will see that in a second. Okay, so casting between elements. So that's the first part of casting we'll talk about. Now you might be thinking that, I've been stating that this is about your data, but while we're using this visual language to talk about our data already, we're talking about curves and areas, and this is all visual language, and that's true, but that's really trying to reflect the shape of the data, the form of the data, and how you can think of it in a kind of abstract way. It's not detailed information that's tying you into that visual representation. So for example, because curve has a similar sort of structure to a scatter, you can easily cast from a curve to a scatter. You're simply passing your curve into the scatter, and then you will get the scatter version of the same thing. So this is what I've just ran. I passed my simple curve into the scatter, and you can see that now instead of connecting the lines in the continuous, assuming continuous trajectory, we now have sample points along our trajectory, right? And you can also see, right. So, yes, now the exercise. Now try doing exactly the same thing where you take the scatter and you pass it a curve, but this time pass it the trajectory curve that we had earlier. This is the trajectory curve that we gave at KDEMs and VDEMs. Just try passing that to the scanner and see what happens there. Okay, hopefully most people have managed to do that. And what you can see is maybe what you might have expected is that we have kept the information that we gave to the curve, and it's now been transferred to this new object, which is this scatter object, right? So we've not lost the information that you gave us about these axes. We know it's still distance for the x, and it's height for the y. Okay. So yeah, the next exercise is just an elaboration of the same thing. Turn the trajectory into an area, and then back to a curve. I'll give you a few seconds to do that before I do it myself. So what I'm showing is what happens when you cast it to an area. That's again what you might have seen earlier. And I've taken a handle on it, called it A, and stick it back in the curve. So you can go from a curve through an area back to a curve again, just like that, by casting these things to each other. Okay, so our curve was defined with very simple Python literals, just a list of x's and a list of y's. But we can use arrays, we can use data frames, and we're going to look at those now. We'll start with looking at arrays. So with NumPy, the appropriate HoloViews element for a two-dimensional array is what we call an image. If you run this cell, you'll generate a two-dimensional array with mesh grid, which has a function of sines and cosines. And of course, if you look at the normal representation of the array, you just get the values. It's not very informative. So we would like a rich visual representation of this thing. So what we do is we wrap it in an image, which is what we've done here. We look at the image, and now you can see the structure. So the next exercise is just play around with this function. Just try visualizing a different image where you've maybe changed the sign of one of these terms or maybe squared one of these terms, something like this. Some very simple transformation of this expression here in terms of sines and cosines to make a different array pattern. Yep. Sorry? Yes, I'll be coming to all of that in the second part. Yeah. Right. So let's just say I want to square the cosine term. I just square this here, create the new image, and we can look at the new array. We've taken sine squared. This is an optional one. I think in the interest of time, I will just kind of show you. Oh, actually, it's fine. I'll give you a few seconds to try it out. So think about how you might want to actually add a proper X label and a Y label to this image. Given what I said earlier about kdims and vdims, remember that an image is two-dimensional. It's indexed with two numbers to index into the array, and the value is the value at that two-dimensional index. So you basically have two kdims, two key dimensions. Okay, if you look at the screen, you can see that I have my image there, and I've just added a kdims list to this image. And this is following just what we did with the curve further up here, where we gave it kdims as a string, vdims as a string, but this time what we'll do is we'll give it two kdims. So let's just say this is, let's say the x is longitude, and the y is latitude. Right. So we've done that, and now you can see that the image has been given different axes labels. Okay. So hopefully everyone's following, and this is, if you have any questions at this point about what I've shown so far, please. Okay, that's good. Okay, so now this comes to the Pandas data frame aspect of what you can do with elements, and you can just simply pass a data frame into an element. The thing about a data frame is it already has columns. And those columns are the dimensions, and those columns already have names. So there's a slight difference. So let's start with loading this economic data set. Let's look at the tail of this economic data set that we have about macroeconomic data. Let's look at the tail of it. You can see a Pandas table. It's got the country, and at the end of the data set, it's Japan. You've got different years at which you've collected your data, and you have statistics like growth of GDP, unemployment rate, and then these two columns that we're not going to use, so we don't need to worry much about, trade statistics. It could be any kind of metric. Now, because our columns actually have names already, when we do our kdims and vdims, we're going to reference those column names. We're just saying that we're going to plot this column as x and that column as y, right? So let's just work through a little example of this. First thing we can do with Pandas is just select a country. Let's just select the data for the United States. So this is United States GDP growth, unemployment over a year. Now we have this little, this new Pandas data frame called US data, which is just about the US. We can pass it to our curve and then say that the kdim, the x-axis, is going to be year, and the vdim, which is going to be the y-axis, is going to be the growth, and that's the GDP growth. Right. So this time, the kdims and vdims aren't strings that you can choose yourself. They're picking a column out of the data frame. So hopefully you can see this at this point. Okay. Right. So for the quick exercise, it's really just changing one string. You can just try plotting the unemployment column of the data frame as the y-axis value instead of growth. And that's just called unem, so unem. I've just run that. All I did is change the growth feed dimension to unem, and now we can see the unemployment rate as the y and year as the x. Okay, at this point you might be worried about these really simple labels we're giving here. I mean, if you want to make a nice publication plot, you can't just use so simple string like unm. You want to give it a proper access label. And you want to give it units, and you want to actually have something that actually expresses what you're actually doing properly. So this brings us to the concept of dimension labels. Dimensions have names, and this is what we've been looking at so far. And they're short, simple identifiers, and they're meant to be valid Python identifiers, things that you can use as a variable name in Python. So what happens when we want to actually have a more descriptive label for our GDP growth? Because it just says growth, we want to say it's GDP growth. Well, HoloViews elements have, and in fact all HoloViews objects have a redim utility that lets you take your dimensions and your element and creates a new element with new dimensions, with new information. So we're going to make a new curve called GDP growth. Well, what we've done is we've taken our growth curve, which didn't have this informative axis label, and we're going to give it a label. And we're going to say it's GDP growth. So it's redim.label, and then you give it the name of the dimension, which is just growth, and you give it the longer name, which is GDP growth. So just to elaborate a little bit, those dimension objects that you saw a little bit earlier, these rich objects now have the correct label. The one which is corresponding to the vdim now actually has the label GDP growth, and we'll see that in a bit. But you can see it right here. So, yep. Right. Okay. So you're asking about column names, which aren't simple strings, essentially. Is that right? Okay. Strings are all fine. So it's a recommendation that you use nice simple literals. And Pandas prefers it too, because you can do tab completion on a Pandas data frame. So it's nice for Pandas as well. But you don't have to for HoloViews. You can use a space. You can use different things. It makes things a little bit trickier for some of the methods. So yes. So as this dimension here? Yes, you can do that. So there's a couple of ways you can do that. One of the ways you can do it, which I won't try to get too sidetracked, but I'll talk about it quickly, is that you can just use redim itself, and then you can basically pass in a dictionary of information to the dimension. The alternative is you can just create your dimension object explicitly and pass it in, and it can have anything you want, because it's just, you don't have to worry about keywords and things not working that way. So here is exactly what I mentioned. The dimension, the value dimension of growth has now a label. Okay. So as a quick exercise, try doing the same thing where we have this redim.label method. Use it to give the year a more useful axis label. So what you might want to do is actually call it time, and the unit is year. So maybe just call your x-axis time, and then we'll see how to add year to it. Has everyone managed to have a go? Okay. So here we go. All I did was add an extra keyword, which is year, and renamed it time. Okay, so I mentioned units. HoloViews doesn't have full-on unit support. It's something we do want to have in the future, where you can convert between different types of units and use an actual unit package that's unit-aware. For the time being, we are doing with simple strings. We just give it a unit as a string. And hopefully in the future we will be able to do fancy conversion and things. But for now what you can do is just use redim.unit instead of redim.label to set the unit value, the unit parameter on that dimension. And you can say that the growth is actually a percentage. So now we have GDP growth in percent. And you can format everything you want. So you can see those parentheses. You can actually customize that to be whatever sort of format you actually want it to be. So I won't be showing that right away though. So if you wanted to do that for the year, which is actually the next exercise, you do the same thing. You do read_in.unit year, because the name of the dimension is still year, and you give it a unit of, so yes, that's right, a unit of year. There we go. Okay, good. We're coming to the next section of this notebook. So any particular questions about what we've seen so far? Yep. It's coming right up. Yep. So this is about composing elements together, and that's exactly the question. How do you start showing multiple things at once? How do you do multiple variables at once? That's essentially the question. So HoloViews has containers, which we'll come to later, but there's another concept, which is composition. There's just two basic operators that we really use a lot, plus and mul. And this is something that you use all the time when you're doing visualization, is you want things side by side, you want things in column layouts. You don't want to have a notebook where you have one thing, then you have another bit of code, and another thing below it. You want to see things right side by side. And this is what we call a layout. And it supports heterogeneous elements. So you can have any kind of element combined in a layout, right? There's no restriction on what the type of the element is. So when I run this, we did the same casting thing that you saw earlier, where we cast our trajectory to different types of elements, scatter area, with a new one called spikes. And what I've done is I've added the plus symbol between them all, which is the plus operator, which generates a layout. It's a new object. It's still an object that is about the data. It doesn't have any information apart from this cols. It just says it's a two-column layout. That's really all it knows about itself, is I have these things and I'm a two-column layout. Right. So, of course, you can change it, but generally the other options are worse. So. Right. To show that, sorry. When you say move, oh, right, they're probably linked, right? Yes, they are linked. This is automatically linked, and this is because they're all in the same space, right? They've all got the same dimensions. That's basically it, because they all linked. They all have the same dimension declarations. When you zoom in on one, it automatically says, okay, well, this plot has also got distance and height, so I'm going to zoom in on that too. And it's something you can disable. So don't worry about. There's just an option I'll talk about later. You'll see how to disable this behavior. And you can have them completely independent if you want. So this is actually often useful because you often will have lots of views of the same thing. You want to zoom in one place and just see everything zoom in. So, yeah. Yep. You'll see that in the tutorial. The basic recommendation, so the way HoloViews really works is we don't copy your data unless we need to, which is very rare that we copy your data. We recommend that you don't mutate your data. It's kind of a declarative approach whereby you actually have multiple elements, whereby the elements are different, they're different objects. The data can be shared, it can be slices, it can be anything you want. But we recommend you don't mutate the data within a particular element. This is something that you can do, but it's risky, and we don't recommend it because we often reason about things being, the data in the element itself being immutable. That doesn't mean that you can't do animations. It doesn't mean that you can't have very dynamic things, as you'll see. But generally, you shouldn't go into the element and mutate it. You can try it, it might work, but we don't give you any guarantees. Right. Okay, so this is the layout. Right, so this is the default representation of the layout, and it's a tab attributable indexable thing. So if I want to select something, I can get my layout, press period, and tab attributes that I want, my scatter, my curve, my area, whatever. And this is just default behavior. By default, we use Roman numerals, which might be a bit weird. We're thinking about changing that. But just as 1, 2, 3, and normally you don't go past a certain number because your layout would be too big to be useful anyway. Right, so let's just say that I pick the area. I just tab completed that. I can pick my spread, spikes, and I'm just picking out that element from that layout, right? Okay, so of course I can take a layout, pick the elements, use plus on them, create a new layout. So I had my two-column layout with 4 things. I can make a 2-column layout with just 2 things, where I've just picked the curve and the spikes. So hopefully that's still quite straightforward. Okay. Is that clear so far? Yeah. Not at this time, no. Everything is it's the original element. Mm-hmm. Basically, I think that's right, yes. Right. Okay, so we looked at this sort of attribute access, and it's kind of awkward, using the name of the element and then these Roman numerals. What you really want to do is actually label your element. So remember that we had labeling of our data, of our dimensions, sorry? We labeled our dimensions, and that was labeling the axes. But now we're going to give a label to the element, and one element can have lots and lots of dimensions, lots of key dimensions or value dimensions, but now we're going to give a label to the element itself. So what we're going to do is going to use the relabel method on our trajectory, and we're going to say this is actually a trajectory of a cannonball. We're going to give it a little bit more information about itself so it knows what it's representing. So what we've done here is this is actually the same as this. You give it the label of cannonball and the group trajectory. So group is a bit more general than the label. You can have a group of things, and within that group, you can have lots of labels. You can, of course, have different groups, but essentially the granularity is group is a superset of the labels, right? You can do the same thing again. This time we're going to use the area. So we cast the trajectory curve to an area element, and then we relabel that. So we're going to say that once you meet an area, it's a filled trajectory. It could be an integral or under a curve. It could be whatever you want it to actually represent. That's what you give it a little group and label. Okay. So what you can see now is I've taken my labeled area and my labeled curve, added plus between them, and now we have another layout, but this time you can see that there's titles being added. We've actually given a little bit more information about what we're looking at, because we have this information about label and group. We now have cannonball trajectory on the left and filled trajectory on the right. So this is, it's worth re-emphasizing that this is a label at the level of the element, not a label at the element at the level of the dimension. Okay, so the exercise now is just take this label layout object, which is in the namespace, and just have a look at the tab completion and try picking an element out of it. And in fact, you can try and build a layout out of things you've picked out of this layout. Yeah, so a new layout from the one that you already have. Right. So the group is essentially a 2-level indexing system, whereby the group is a little bit more general than the label, and it lets you do this 2-level access. It's hard to give it a very strict definition. You have to think a little bit about your data. What class of things are you working with? Yep. Okay, yes, that's probably a good idea. So yes, that's probably a good idea. We'll be able to answer that in a bit. So we have our 2 trajectories. So I'm just going to do this myself. Label layout dot trajectory dot filled plus. So I've just swapped the 2 things around as per the exercise. Okay, and I don't think it's that interesting to actually do. I'll just show you that you do have dictionary style access of these things. Right. So you can do it in that style. Tab attribution, tab completion is pretty useful in the notebook, so we tend to use that. Okay, so is everyone following? Okay, great. Yep. Right. So yeah. Right. Yes, this is the new name. That's correct. So yes, that's exactly right. So earlier on, you saw that you had this default system scheme where we hadn't given the label in the group. We were using the default access, which is the type, and then this automatic Roman numeral. But now that we've actually specified a group and a label, thank you, actually, this is something I did want to say, you can now use the new group and label in your attribute access. So I should make that clear. So you can see that we're now using trajectory.filled because it's the trajectory group and the filled label. And it's actually using that information about group and label for your access in the layout. So just to be completely clear about that. Yep. Oh, this one, yep. No, it's not. This is 2 levels of actual dictionary access. Oh, so that might be an internal detail that you've actually abused. It's not what we expect, but it works. Right. Okay, so this is going to be much quicker. So just to make sure I don't fall behind time too much, overlays are really almost exactly the same as layout. There's very little different about it except what they look like. They have the same attributable indexing. They are basically the same kind of structure. They're heterogeneous. You can take any element and combine it in a layout with any other element. The main restriction, they have to be in the same kind of space. So they really have to share the dimensions. They at least need to be in the same kind of space. So let's take our trajectory and we use the mul operator to make an overlay with the spikes. So now what we've done is we've taken our spikes and we've stuck it on top of our trajectory. And because they're in the same space, they're happily living together. Right? If you had something in a very different part of the space, then you'd have troubles visualizing it because it'd be zoomed out or something like this. Okay? And as it says here, this overlay has an identical kind of indexing scheme. So, right. So you can mix and match. I think we'll skip this exercise just in the interest of time. Okay, so we're nearly at the end of this notebook. Okay, so this is showing you that you can actually start combining things in more sophisticated ways. You can have a layout of overlays, right? You can have something which are in the layout which are overlays, and something which aren't, and just elements, and so on. What we've done here is actually set the label, which we talked about earlier, as tennis ball and cannonball. So these are the labels. Cannonball already existed, so we just taken cannonball, and we used the clone method, which basically creates a new instance of the element, and all we've changed is the label. So I don't think you need to worry too much about this, but the clone method is kind of a useful idea because it tells you that most things in HoloViews are clones of various sorts. You're getting new wrappers around your data. So you're not mutating the wrapper, you're just creating a new wrapper around whatever data you had. So when you do this, you can do cannonball plus tennis ball, which is the left and the right, and then you can do with parentheses, just to make sure it's not ambiguous, mul, the 2, and you can see them in the same space. And here you can see the effect of the label in a layout. You can see that it's labeled it correctly. You have a color cycle where you have red and blue, and the one which is tennis ball is red and the cannonball is blue. So that's one difference between overlays and layouts. You're not going to have that concept in a layout. It's only when you overlay things you want to use color cycles and legends and things. That'd be the second notebook. We'll come to that. Okay. So how are we doing for time, you think? Ahead of time? Okay, so in that case, I'll let you try the exercise here, which is to use the clone, which is just the same thing you saw above, but let's try and make it half the height. And let's add it, and we call it a thrown ball. So it's something you throw with your hand. You expect it to be shallower than what you might be able to do with a tennis ball, and just add it to the overlay. Okay, so I'll show you what solution I came up with, which is very simple. I just copied and pasted the clone. So multiplying it by 0.5, I multiplied it by 0.25, so it's a shallower y. I give it a new label, thrown ball, and I just added it to the one above just to show you it in the context of the layout, but I also just made an overlay here as well. Yeah. Yeah. So what you've done is you've taken the data that you had originally, the lists, you've multiplied the y's by, you've halved the height of the y's, and then you've made a new clone of that wrapper with that new data and the new label. You're cloning the wrapper, not the data. Well, you've actually supplied new data in this case, but exactly. If you don't supply new data, it would just be exactly what you said. It wouldn't be cloning the data. It would be just cloning the wrapper. Okay? And the last thing I want to talk about in this tutorial, in this notebook, is there's a lot of things that HoloViews offers in terms of slicing and indexing and selecting things. We're going to talk a little bit about it later, but I don't want to get into too deeply now. Essentially, when you have an element in HoloViews, you can slice the dimensions. You can say, I actually want this curve from this point in the distance to that point. I want to slice it for this region of the space, or this y region of the space, and so on. You can slice your dimensions. So I think the thing to really note is that HoloViews uses the actual values of that dimension. It's not using integer indexing of some samples. You're actually using the space in which the samples live. So if you have your x's are distance, then when you slice, you can give it floats. So you can say, I want it from this distance, from 5 meters, 5.2 meters to 10.3 meters, right? And it will take the samples that fall in that range and then display you that. Right? So what I've done here is I created an overlay of an ascending region and a descending region. And again, you have the labeling due to the overlay, and you can see that one's in red and one's in blue, and that's because I've sliced my curve in half, where I have selected from -10 to the center for one, and I've used zero distance to 10 for the other, and I've done it in slightly different ways. One is using this array style indexing, which is just the first dimension. This is just the distance dimension, the first key dimension, the x, -10 to 1, and that's the ascending curve. And the second one, I'm using a select method, which you give your dimension names as a keyword, and you say, I want it between 0 and 11 meters. Assuming it's meters, I could have given it a unit. So that's just to introduce the idea of slicing and indexing. So if we want to go beyond, our curve is going, our data goes from -10 to 10. And let's just try it. So you mean, if you expand the slice beyond what you actually have, then it's just going to use the data that you actually have. Does that make sense? Right. Okay, so that's actually a good point. We do follow the normal Python semantics of inclusive lower bound and exclusive lower bound, but you have to be a little bit careful because they're floats. So, but basically that's what's happening. Yes, exactly. I can't tell you offhand. We are using Pandas for things underneath. So when we support date times, it's via Pandas. Okay, well, that's a good point. That's something to think about. Maybe file an issue. That's a good point. Okay, so let's move on to the next tutorial. Okay, let's see. So hopefully everyone's understood the idea of elements. They're there to hold your data. We're not really been talking about line styles or color cycles or anything like that. They're just there to know what your data is. So if you go back to the index notebook, and let's go to the second. I'll reset my timer, make sure to stay on time. Okay. So has everyone managed to get the second notebook up and running? Has anyone not been able to do it? Everyone's now running? Great. Okay, so usual import at the start. Again, we're going to import pandas. We're going to use pandas here. And we're going to import HoloViews as HV. And this time, we're going to load the extension with 2 plotting extensions. Bokeh is still going to be the main thing we're going to use. But just to demonstrate that we can do this, we can also use matplotlib. So we basically loaded the capability of viewing everything with both Bokeh and matplotlib into the notebook. But right now, only Bokeh is active. And you'll see how to switch between Matplotlib and Bokeh in a second. So for this, we've got quite an interesting little data set due to solar eclipses. This is kind of neat. This is all the eclipses that are going to happen, in the 21st century, so from 2000 to 2100. We have the date of the eclipse, the hour locally, which means noon is when the sun is right above your head in local time. You have the hour in UTC, which is in Greenwich. Types of eclipse, so total eclipses, partial eclipses, annular eclipses, and so on. The magnitude of the eclipse, which is basically how the angle in the sky that the moon is casting against the sun. And finally, the latitude and longitude at which you'll get the maximal eclipse. So this is just another data frame. And we're just going to pass it straight into our curve. Now here's what we get. This is an example of some real data instead of some simple parabola. Now we look at this, and you can see a whole bunch of things you want to improve visually, right? The main thing that would bother me is there's clearly structure here, but it's very compressed horizontally. I want my time series to be taking up the whole width of the screen so I can easily see the structure here instead of just being forced in this little square plot. So this introduces the HoloViews option system. Now options don't live in the elements. They live completely separately. They have their own little system in HoloViews which keeps track of basically your choices in terms of aesthetics, what colors you like, what color maps you like, whether you want a color bar or not. All this stuff is kept separate from the elements. All that links them is a little ID that you don't need to worry about. There's a little integer ID on each element that will make a link to its customizations, and that's handled for you. So you don't really need to worry about that. But you can customize individual elements. You can customize them globally as a group, and we're going to look at that now. So the basic thing you need to know is that all options in HoloViews are keywords. They're just simple keywords for the most part. Things like color is a red, and that's a string red. Color map is viridis, this kind of thing. Very simple keywords that come in 3 different types. The ones I just mentioned are what we call style options. They're aesthetic things, generally colors and line styles and that kind of thing. The other thing that we have, which is actually listed first, is plot options. And the plot options are HoloViews API. These are defined by HoloViews, and what they do is they tell HoloViews how you want to build the plot. Should this plot have an x-axis that's visible? Should I hide the x-axis? Should I use some, polar coordinates? Should I disable the title? This kind of thing. And these are instructions to HoloViews. And then finally, there's normalization options I will not be talking much about. They're very important. They're about how you compare data with different things to make sure the things are in the same range, different types of normalization in terms of being able to see the structure across plots or across time. But I won't be talking too much about that. So the really important thing I want to get across is plot options are HoloViews API. Style options are just passed straight through to the plotting extension. So these are Bokeh keywords or Matplotlib keywords. It depends on what you've actually got loaded. Right now we've got Bokeh loaded, so it's going to be Bokeh keywords we're going to be using. Okay, so I'm going to go in the order that we've listed them here. Plot options first. And here's my plot again with what I wanted stretched out on the x-axis so I can actually see what's going on better. Right. So I'll have to unpack this a little bit. The hour curve you can see is actually all the same stuff that we discussed in the first notebook. Redim.label. There's nothing new there. It's just setting the labels. It's what you've seen already. What's new is this line here at the top. This is what is called a cell magic. So maybe I should just ask, who's familiar with the idea of IPython notebook magics, like cell magics or line magics? That's good. That's most people. So for the people who aren't familiar, this is cell magic because it has 2% signs at the start, and it has to be at the top of the cell. You can't put it in the middle of the cell. You can't put a comment above it. It has to be at the top of the cell. And what this is doing is it's saying that the curve that I'm going to be displaying in the cell, give it a width of 900, right? So this syntax is IPython specific. It's using this magic system. But everything I'm going to show you can be done in pure Python without worrying about magics, without worrying about any syntax that's not pure Python. I won't be talking too much about it because we are in the notebook and this is very convenient. But don't worry if you think this is all tied to the notebook, it is not. So the square brackets here tell you that we're doing plot options. So this is a convenience that you have to learn, I guess, and it's there to be really succinct. So to keep things really short, we use square brackets to mean plot options. So this is the things that we tell HoloViews. We use parentheses to do style options, things that we're going to pass to Bokeh or Matplotlib. And we use braces about normalization options, which I won't talk about much. So because I've used the square brackets and width as a keyword inside those square brackets after curve, I'm saying this curve is going to have a width of 900. Right. So hopefully that much is clear. Is there any questions about that? So what you can see is that the first line is talking about aesthetics, what it looks like. The second line is our data, it's our element, right? And they're not actually mixed. So the HoloViews keeps them linked, but your element is separate. If you pickle it, it doesn't know anything about the width, right? If you inspect the curve object, you will never see anything about width there. You'll just find this little ID that I mentioned. There's nothing much to worry about. Okay. Right. So just as an exercise, same way we have width, try height. Try height 500, for example. And note that you have tab completion. So I can, when I'm in the square brackets, I can press H and I get height as a suggestion. Press tab, I can see all the different plot options that are available. The one we want is height. So it should be nice and quick. So I'll just demonstrate it now. I've used a height of 500. It's kind of ugly. It's much higher than we need it to be. So let's just go back to, let's say, a height of 300. That's more like it. I can now customize my height instead of using the default. Okay. The second exercise should also be very quick. It's a Boolean option called show grid. So again, you can do tab completion, and you'll see show grid here. Just try setting it to true. Okay. Has everyone had a chance to do that? Yeah. So, is everyone following okay? Yep. You'll see in a second. We've got that. So I'm going to just do show grid here. And it probably did what you expect, I hope. It shows a grid. There we go. And the final example of a plot option is let's just add an X rotation. Yep. Is it, sorry? Yes, because it's a cell magic, it's applying itself to that thing that you've displayed in that cell. And it persists, as you'll see in a second. So it's slightly breaking the semantics, I guess, slightly, because it actually persists. So you could argue about that, but it's very useful that it persists, as you'll see. Yes. This is part of it. It will only work on magic lines, because that's part of how IPython lets you do auto-completion. And it's set up so that when it sees %% opts, it does the auto-completion on that line. So, yeah. Okay, so let's do X rotation, 90 degrees. And now I've just rotated all the X labels by 90 degrees. So hopefully that's introduced the idea of plot options for you. Okay, there's a little aside here where, in terms of getting docs, there's a fairly extensive help system in HoloViews, which is just hv.help, and you can give it an element. So let's look at information about curve. I hope this link works. Yes, it works, because we recently updated our website. So it's very pleasing that it works. So you've actually got a link to the element. You have style options. It just lists all the style options. So you can, instead of relying on tab completion, you can have a look here if you're not using the magics. This will work in a standard Python terminal. You don't need to be in a notebook. Then you have the plotting options. So this is all the things that you can tell HoloViews to customize. You can see height, which we used. You can see show grid, which we used, and so on. And then all the doc strings below. So that should help you figure out what you need to do to get the plot the way you want it. One thing which is kind of neat, sort of a user requested it, and I think it's quite a cool idea. You can actually do little searches here. So if you just pattern equals LOD, you'll do a substring match, and this is a bokeh LOD parameter. So, and this is a plot option. So, okay. So I do recommend you look at hv.help if you find particular issues you can't find what you're looking for. Do look at hv.help first. Okay. So that was the plot options, and now let's move on to style options. As I said earlier, style options are in parentheses. You don't use square brackets anymore. Those are plot options. You now use parentheses. And here we have a curve, plotting a bokeh, and we're using the line width and color keywords, which are passed to the glyph, which bokeh is using here. So this is a bokeh's API. HoloViews never defines line underscore width anywhere in its code. It just passes it through to bokeh. Right. Of course, I can do things like change the color, and so on. Okay, and one thing to note, have you noticed that this curve is still wide? It's still wide. So earlier on, we had this horrible compressed curve. Then we did the plot option with the square brackets, and we fixed the width. And now we don't have that anymore, but it's remembered to be wide. It's remembered what you told earlier and how you want it to look. So it's kept the wide format, which is what you wanted. And now you've just changed the color of the curve or the line width. So, the exercise is just to redisplay the same curve without any magics at all. So if I just do this, you can see that this curve remembers its styling without having to repeat yourself with this cell magic at the top of the cell each time. Right. Yep. Actually, we'll be using that later, so I'm actually really happy you asked. There are multiple ways of doing options in HoloViews. There's utilities, and there's one method called ops. And if you just do that, it resets it. So you're back to what you had. But now, of course, if you want to get back to that, you'll need to go through it and customize it again. Ops does, actually, sorry, yes. Ops does return a copy of your curve, so you're correct, exactly right. You get a new curve with those options reset, so your hour curve is actually still untouched. But that's easy, you just grab a handle on it. You can override it if you want. Okay. Yes, fairly sure that's right. Brian will correct me in terms of bokeh, but I'm fairly sure I can just do, is it 0 to 1 or? Sorry, RGB tuples, 0 to 1? Is it 3? Color tuples. Okay. Yeah. Okay, so I can do this then, right? Oops. Okay. I do know that you can use hex colors, so you can use HTML hex, right? That's probably what I'd recommend here. Okay. That's actually annoying. This should have been fixed. Anyway, so what I'll do, so there is an issue that we sometimes have where if something goes wrong and you remove the thing that went wrong, it's still broken, and hopefully we'll fix that soon. So I'm just running through this. Okay, so that's what we're up to. And I can make it, you can set the line width, which is one of the options here, line dash. So we can set line dash to dot dash. So, oops. Oh, of course. There we go. So we set the line dash to a dot dash style again, pass through to bokeh, and bokeh handles that. Okay, so earlier we had a question about matplotlib and using matplotlib. To do that, all you need to do is use a different magic called the output magic, where you specify that I no longer want to be using bokeh. We at the beginning of the notebook, we loaded the capability of using matplotlib, so let's switch to matplotlib and use that instead. So if you run that, you will see that we're now actually using matplotlib. This is no longer bokeh plot. We've gone from letting HoloViews render things with Bokeh to letting HoloViews render things with Matplotlib. Right. And by the way, I know the notebook on the screen isn't quite what you'll be seeing when you run this, because I ran an extra cell ahead earlier, so that's the result of running this. So of course, Matplotlib is not the same API as Bokeh. It doesn't have same keywords. So for example, here, we use style options and plot options again, but our style options now use line width without the underscore. And that's because that's what Matplotlib uses. It doesn't have a line underscore width option. It does have a line width option without the underscore. So here we go again with Matplotlib. Okay, is everyone following so far? Is everything clear? Any questions? Yeah. Yes, with Bokeh you can do that quite easily. There's okay, I might try it very quickly. Well, actually I'm using Matplotlib right now, so I'll show you in a minute. I think you'll see that. Okay, so hopefully that makes sense. The idea that you have different options depending on the plotting extension. Okay, so that introduces the output as a cell magic. Again, it's the same thing. It applies to the output of that cell. Now what we have is the output line magic, which is a global setting. So you run this line magic, and it says, okay, for the rest of the notebook, until I change it, keep using Matplotlib. In fact, here, keep using Matplotlib and output to SVG. Okay, so I've taken this Matplotlib curve, and now I'm using SVG. And this is about it for Matplotlib. I know the tutorial was focused on Bokeh, but I just wanted to show you that these concepts do generalize to other plotting extensions. Yep. Oh, right. So you mean like ag and things like this? Yes. NB-ag is something that we had. It probably still works. I've not used it in a long time, but you could, for example, switch to NB-ag. Okay, so when you did the extension, that basically does the imports of Matplotlib. That's where Matplotlib gets imported and becomes available for HoloViews to use. Behind the scenes, I think it comes up later, there's something called a renderer. There's a Bokeh renderer, which does all the Bokeh-related stuff, and there's a Matplotlib renderer, which does all the Matplotlib stuff. And when you switch, all you're doing is switching your renderer to Matplotlib, and if you want to switch, you can switch back to Bokeh. So the exercise, I'll just do it very quickly. It's just to confirm. Opening a new tab. It's there. So this is just to show that we do have SVG. If you look at the data, it's image SVG. So we've rendered SVG to the notebook instead of PNG, which is what we were doing before. And that's because of the output magic. Yeah. Yes. That's right. Because it persists that those plot options, and it associates it with that element. So it's associated with that element so that it remembers what options it was given. What you might want is to set things globally, and that's to use the opt line magic. And I think there's an example in a second. So it's all customized for that thing that you showed. If that makes sense. So it's probably worth making it clear. So if I just make a h3.curve, it's not got those styles. It's a new element. It doesn't have what I said about width. That was just for this particular curve. Okay, so back to Bokeh, and I think that's it for Matplotlib for the whole tutorial. I've used the line magic to switch the backend back to Bokeh. And hopefully, if everyone managed to do the environment update command, you'll have pulled in Phantom.js and Selenium, because Bokeh now supports some export functionality in terms of PNG and SVGs coming up. It's all very new, and HoloViews supports it. It takes a little while, because I think Selenium needs to kick up. Hopefully this worked for you. If it doesn't work for you, that's not a big problem. It's only a tiny part of the tutorial. Right, so that's now exporting to PNG from Bokeh. Right, this is like a screenshot, effectively, of what the Bokeh plot would be. Yep. And we can check it by ls*PNG if that will work for you. Did that work for everybody? Did it not work for anyone? Did it work for? Didn't work? Okay. Okay, so maybe I wouldn't worry about it too much, because those. Yes. Okay, so coming to the end of this notebook now. This is kind of a more sophisticated example. It's kind of quite nice, I think. We're going to use the Eclipse data set that we had earlier. We're going to split our eclipses now into total eclipses and partial eclipses. We're just doing a simple Pandas operation to do this. We're selecting the ones that are total eclipses and the ones that are partial eclipses. Now we're going to use the ops line magic. So this is a global setting. This is saying that all the spikes elements that I'm going to show from now on should have this width and no y-axis, right? It's not just for that one cell. Okay, so this might look like quite a bit of code, but there's nothing actually new here, except for what happens when you actually do it. The thing that is new is that you can use the group label system that I introduced earlier, that gave you the title and gave you the legend and so on, to actually address a particular element. You can say, I only want the total eclipse to have a solid line style, and I want the partial eclipse to have a dotted line style. And I can do that using my ops cell magic by doing type, which is spikes, dot group, which is eclipses, dot type, so total or partial eclipse. Right? And what I've done is I made an overlay with a null operator, and all the concepts here have been introduced already, except for that change up here, where we've said we want different styles depending on the label. So hopefully that works. So I guess removing 2 lines is very easy. It shouldn't take, there's nothing to it. What's the effect of removing these 2 lines? Well, we're actually creating new spikes elements, right? But remember that we actually set the line magic here. So we said all spikes should have this width and no y-axis. There we go. And because we removed that specification about the, because we created new elements and we've removed the specification about total eclipses versus partial eclipses having different line styles, they all have solid lines. I hope that's clear. So this is useless now because you can't distinguish between the 2 types of eclipse. That's why you want to do have different styles for the labels, so you can actually see the difference. Okay, I think we can skip that one exercise. I think, yep. Yep. That's correct. It creates an entry in something called the options tree, which says if I have a match for this, this is how to style it. Right, you're right that it creates it and then matches it. So, okay, so I don't know if I should push ahead to the next tutorial, and then after that there's a break for 15 minutes. Should I push ahead or should I do these exercises? What do you think? Okay, so I'll push ahead. Okay. So everything you've just seen applies to the next notebook. Exploration with containers. So we're not going to be talking so much about options anymore. You will see an example in this notebook of options still being used. Everything still applies. But now we're going to talk about what happens when you have lots of elements and how you can actually view them together. Okay? So let's run the first cell, load Bokeh with the extension, and we'll immediately use a line magic to say that all curves and areas should have a width of 600. And this is a good practice, I'd say, is to put your global settings at the top of the notebook so people can see them and they'll just apply to everything else. Okay, so now we're going to do something which you haven't seen before, which is to declare an element in a function. We create a function that returns an element. Right? And this is quite good for a number of reasons. It's nice to parameterize what the element is, and it lets you do all sorts of things. You can load the data of disk in the function and then output the element. You can query something online, some remote resource, and make an element from that. You can compute some mathematical function and show that. Or maybe you have a simulation, you access the simulation state and visualize some of it. And it's easy to do all these things when you have a function. So here's a little function that's doing frequency modulation, and you'll see what I mean by that in a second. It's got a whole bunch of default arguments. And all it does is it makes 2 little NumPy arrays, just like we saw earlier, curve. It sets the dimensions, time and amplitude. So here's what happens when you run that. This is the curve that we got. And of course, because we set that line option earlier, it's got the width that we wanted. And what it's doing is basically you have a carrier frequency and then you modulate that with a certain strength by the escape my head. The carrier. You got the carrier frequency and the modulation frequency. That's right. So this is the curve that we got from our function. Now, let me introduce the first container that HoloViews has, which is called the HoloMap. You can think of this as a high-dimensional dictionary. It's essentially a dictionary. It's just a Python dictionary. We have keys, which are dimensions, key dimensions, and your values are elements. So you can often do dictionary comprehensions to declare a HoloMap. And in fact, this is what this cell does here. Right. What we've done is we created, for this list of modulation frequencies and this list of carrier frequencies, we called our function with those arguments, right? Right? And that creates these curve elements as the values, and the keys is the carrier frequency and the modulation frequency. So this thing here is just a Python dictionary with a whole bunch of elements, right? But once you have a HoloMap and you put it in there, you actually get sliders. So we can now actually browse the elements with sliders. We can scrub through this parameter space that we basically defines two-dimensional parameter space, where you notice that we've declared kdims, key dimensions, for our HoloMap, FC and FM, which map to these two sliders. And now we can just scrub through and look at our data. Okay. So here's the first exercise. This time we've supplied a function, but this function only generates the arrays x and y. So essentially, you can just use the same thing again. You can create a curve, return a curve from this function. Right. So that's, and we can use the same kdims for the curve. Okay. And now we can make another HoloMap. All we need to do is switch our function that we had before, which was FM modulation, with FM modulation 2. So I hope everyone's able to follow so far. All we've done is we're creating a HoloMap with a different function. So actually, I've used curve. I actually want to use area for this exercise. So now we're turning an area element. Just to display it. So, any questions? Are there any problems? Has everyone managed to get some widgets up? Anyone not been able to get some widgets up to explore? Yeah. Yes. Sure. I'll actually make you. That's fine. I'll actually create a very simple example. So. Let's just make a very, very simple example. So I'm going to make a curve where I have the value 1, the value 2 times I, the value 3 as the data of the curve. So that's the value in the dictionary. I is the key, right? Okay, so I make 10 values where I goes from 0 to 9. And I will multiply just the middle value, that's 2, by that. And I just declare that my key, that there's one key dimension is called, let's just call it index. Right? So this is just a very simple example where I've just created a dictionary of elements. I stick them in the HoloMap and now I can explore that space. I hope that's a little bit clearer. No, this is just a nested dictionary comprehension. So it's basically, our keys are tuples, and we're ranging over both the carrier frequency and the modulation frequency. It's one dictionary. Yes, exactly. You have tuples, and you have a first position, which is the first key dimension, which is the carrier frequency, and the second one is the modulation frequency in the tuple, and that's why you get 2 sliders. So is that clear? A key. So we call them key dimensions are the things you index by, and we're indexing our holomap by these two sliders. Okay? Yes. That would be quite straightforward. Actually, I could do that now. So I know that FC is my first dimension. Let's just pick 110. So FC is the first dimension, the second one's FM. So I can just pick it like that. So I've reduced that dimension to nothing, so it's just one value, which is 110, and now I just have a single slider. So I hope that helps. Any other questions? Yeah. I think if we don't have an example, it'll definitely be one. Yes, you can use the plus operator and the mul operator and all this stuff. So you can put things next to each other, and you'll have the sliders. They're linked if they share the dimensions. Okay, so on to the next thing. So holomaps are really great for certain things. Because you've got a dictionary, you've got all your data in memory at once, which means that you can export these things to a static HTML file. You can email it to someone. They don't have to worry about live server. They can just play around with widgets. It's great. The thing, of course, is going to explode your notebook if you have a huge parameter space. Your notebook's going to be kind of huge. You don't want to send people huge HTML files. So at some point, you need to use a live server. So dynamic map is just an extension of holomap, which is actually quite a lot more powerful. And it does require a live server, but now I can just ask my function for the values I want as I want them. So it's lazy. I just request what is the curve for this, this, and this. And as I'm exploring, I can get those values in. So we're just going to use that same function we had earlier. And now we have 3 sliders. And we can do this because we can have 5 sliders. We can have 9 sliders. We don't need to worry anymore about this explosion of elements. Because if you have 10 values and you have 5 sliders, you've got 10 to the 5 values, you're going to run out of memory, right? But if you use a dynamic map, you're requesting things dynamically, so you only require as much as you're looking at. The other nice thing about dynamic map is look at all the values I can script through. I'm really no longer limited in the number of samples I have. I don't have to make a giant dictionary. I can just request the values I want. It's quite fun to play with. Right. Exactly. Exactly. So when the slider is at this position, that's what's going to ask the function for, and that's what's going to show you. So it's a lot more memory efficient. The biggest downside is needing a server to do things. So you need a live notebook server. Okay. So that's going to be down to how quickly the WebSockets connection works, how quickly things render, and all sorts of different factors. Right. That's down to things like debouncing, throttling. There's kind of things that you need to do to make sure that you don't queue up too many events, this kind of thing. And sometimes it's hard to get right, but I'm sure we're working on different approaches to that, and we're going to have improvements to that, I think, coming. Okay. That was 30 minutes. Okay. Yeah. Mm-hmm. Here, this one is a 3-dimensional one. We've got 3 sliders, right? And these correspond to the arguments of the function. So actually, that's a good point. So here we have the kdims, and these strings are now the argument names of the function that we call. So it's saying the f carrier slider value, pass it to the f carrier argument of the function, right? And the same for fmod and mod index. So if you just look at the definition of our function, we have all those arguments here. And then we just pass them in. And because we declared 3 of them, we get 3 sliders. Okay. So yeah. Yes, so I'm going to show you that. So the other thing that you need to know about dynamic map is you declare these dimensions, but you don't know the ranges, right? this is why here what we've done is we've used redim.range, and I should have explained it a bit better earlier, to say that this dimension has values from 10 to 110 for f carrier, same for f mod, and mod index goes from 0.1 to 2. And this defines the ranges on the sliders. And this is information that's on the dimensions. So we saw redim earlier. This is the range property parameter of dimensions. And that's how you define the slider limits. And to answer the question, yes, there's something called values, which we'll see in a bit, where you can specify the points along the dimension that you want sampled. So have a slider that snaps to those values. And I think you can use an array for that. Okay. So I think I'm gonna move on. Hopefully, so I'll just very quickly describe what's going to happen here. If you actually do redim.step, it's very straightforward. It just tells you the interval that your slider jumps by. So actually, I'll just do it very quickly. I see what I've done wrong. I was looking at the wrong slider. I know what I'm doing. Okay, that's what I wanted. I've taken the mod index, and I've just said that the step is 0.1, so it's jumping by 0.1. That's all that exercise was. Okay, now we're going to look at faceting. So we had the holomap, which is in this dictionary, which you can explore with sliders, but there's lots of different representations you can use when you have a bunch of elements. So here's one. It's called a grid space. What it does is it lays things out in 2D. We have 2 dimensions we're looking at here. Because our holomap, if you remember, didn't have 3, it had 2. Well, I've removed one. This is what it looked like. And those 2 dimensions can be laid out in space. So instead of having a slider, you can say that actually I want map FM along the y-axis and FC along the other axis, right? This is too big. Right, let's make it smaller. I think it's because I've been messing around, and sometimes you have some state that hangs around, but you basically should see the whole plot where you have different values of your modulation along the x and different values along the y. Right. So does everyone see what they expect to see for the grid space? Yeah. Should maybe just regenerate my holomap. It's far too long, essentially. So I think I must have done something funny in my notebook here. Okay, so that was the grid space, where we're taking the holomap and we cast it to this thing that lays things out in 2D instead of having sliders. Another thing we can do is the overlay method. So this is no longer casting, we're using a method. And we're going to say, we want to actually create an overlay. So we talked about overlays earlier. We want to create an overlay where we basically overlay the frequency modulation. So you see all the different frequency modulations here, right? And then you have the FC slider that you can move around. So you've basically taken 2 dimensions. One is still a slider, and the one has become an overlay. So you can see it all at once. Right. And that argument tells you what you're overlaying. Okay. So let's move on to the next one. This is related to the question I had earlier about passing an array. So this is the values property of the dimensions. And what you can do is say that I want my dynamic map to be sampled at these particular values, not just a continuous slider range, but 10, 20, 30, right? And I can do that for 2 dimensions, f mod and f carrier, right? And that's going to create that's still just a dynamic map with 3 sliders. And I'm going to say I'm going to overlay one of these dimensions into fmod. Fmod is going to be an overlay now, right? I'm going to chain that into grid. So you can chain these different operations to create kind of quite a varied number of plots. So here there are legends. You have 10, 20, 30 as blue, red, and yellow. But when you do the last step, you can say that dimension is now going to be a grid. So this is just another way of taking our data and laying the dimensions out in different ways. Some of it spatially, some of it in an overlay, and some of it with a slider. Okay. Right. So earlier I talked about slicing for elements. You can also slice holomaps, where basically you're saying that I want these keys from this range to that range. So the keys are, again, a dimension, so they have real values, like, I don't know, distance in meters, so on. You can say I want the holomap to have keys from, again, 5.2 meters to 11.3 meters. You can slice down a range of keys to a subset of keys based on the values you want in that dimension. So here we're doing that using the getItem syntax. And we created a new plot where we have holomap, an overlay. Right. So I think, yeah. Right. I basically messed up the sizing in my notebook, but everything is working. It's just I'm having to scroll when you shouldn't have to scroll. So the last one, we're using the select method. So we again introduced that for elements. You can use select to say that my holomaps, my dimensions, I want it from for this particular value, or I want this particular range. I can just slice and dice my data whichever way I want and retain a visualization which is either with sliders, with overlays, and so on and so forth. So I've tried to go a bit quicker on that one just to try and catch up on time. So I'll now allow some questions and see what particular things might be confusing people. Yep. Right, so that's a good suggestion. We have a partial one of those. I can fill in the rest and I can send that out to everyone. That would be maybe a good idea, so that you can actually see the same exercises again and see the solution that we suggest. That's actually a good idea. So we'll do that. Okay. Any other suggestions or questions? Yeah. Yes. Oh, you could. It's just that I think I got myself confused. Because fmod and carrier, those are 10 to 110, so they're much bigger ranges. And I could done exactly that. So I just chose a small float range, which is the fmod goes from 0.1 to 2. But I can easily do, let's say, fcarrier. And let's just say we want it to jump by steps of, I don't know, 10. So I've set fcarrier. Oh, what have I done? Right. Okay, so hopefully, I don't know if Jim can answer that. I mean, I'm kind of wondering why it's not working here. Right. It does work for the float example. Okay, so yeah, so I think we'll have an issue and we'll look into that. So, but I did get it working for one of those dimensions. Okay, so anything else before we have a break? Yep. Right, if you're using the holomap, there's no problem, because that's got all the data right there. It's in the HTML, you can put it online, and we actually have examples on our website just like that. But if you have the dynamic map, which we're using now, or have been using earlier, in fact, we used it earlier, that requires a live server. So you need to have something backing that up to feed you new values of your element. Right. So it depends on what you pick. Yep. Mm-hmm. Yep. Right. So if you try and do that, generally you'll end up with something really zoomed out. So if you've got different parts of the space, it's going to try and incorporate this part of the space all the way up here and then this part down here. So your plot's not going to be very useful because you've chosen things which are at very different parts of the space. a different length of rays for like a curve should be fine, for example. You could have a curve with 20 things in it. You should be able to overlay it with a curve with 10 things in it, no problem. So I'll have to look into that. Yeah. Okay, which input? Right, okay, I see. So these things should be floats, right? That's because if it's integers, we assume that the whole thing's integer, and we have a little bit of logic which says if it's float, we'll let float values work. Well, we do have integer sliders and float sliders, and if you just use integers, it's thinking it's like integer slider. Yeah. Okay. I think that's it. If there's any more questions, we'll take a break. I'd just like to start by saying one thing that was a little bit of a mistake in the last notebook was a last-minute change which was not thought out properly. I added this little line to show you that even with dynamic maps, you can use the option system. So you can use color equals red, and it works with the option system. That might have messed things up for you later, because you then set things to be red when they shouldn't be. So just to say that if you restart the notebook, clear everything, it does work as it was supposed to. I guess in notebooks, it's really easy to make a mistake and then you screw up everything else just because everything's in the same namespace. So that's all the way it should be looking. So hopefully for you guys, it worked correctly. So, okay, so now I'd like to talk a little bit about working with real data. So real data sets, we kind of have already. The Eclipse data set was a real data set. And we'll come back to the economic data set next. But we're going to take a little bit of a different approach. The difference with what we're going to do now is we're going to start with a data set in the abstract. We're not going to think about curves or areas or any specific element. We're going to start with just saying that we have this data and we want to explore it. We've not even thought about what we're going to look at it, what its visual representation is going to be, right? We're going to start doing this first with tabular data, which will be a Pandas data frame. And later we'll look at similar concepts, but with X-array. And that's going to be array data. And then the last 30-minute section will be showing you how you can start adding events and driving things in HoloViews with external output. So it's a little bit of a digression from the first two, but that will lead into the last section of the tutorial. So if you can all open the fourth notebook, working with tabular data. Okay, so the beginning is the same. There's one new import, which is SciPy stats, which we'll be using in a little bit. And again, we're going to use Bokeh. And one thing we've done is we've enabled the hover tool. So earlier we had a question about being able to hover on plots to see data. This is the tool that you use to do that. This will let you hover on your Bokeh plot and see what the values correspond to. So the data set we're going to do is actually revisiting that economic data set, the macro data set that had growth and unemployment statistics and countries and so on. So the key point about this format is it's what we call nice, tidy data, whereby columns are the variables, which actually become dimensions in HoloViews, and each row is an observation, right? So what you can see here is that you have country and year and a whole bunch of economic statistics for that country and that year, right? And you can imagine for a given year in a given country, you could have different sets of metrics you're measuring, right? So what we're going to do now is instead of having a HoloViews element that has a immediate concrete visual representation as a curve, an area or something, we're going to use basically it's the superclass of all HoloViews elements. It's called the data set, right? All HoloViews elements inherit from data set. The data set is the thing that holds your data. Now, I just mentioned that you have data for a given year in a given country. And that's what you're indexing by. You're basically saying you're indexing by country and year, and then you have a whole bunch of measurements that have been made, right? And you can have a huge number of measurements, you can have different metrics and so on, but it's all for a given country in a given year. So what we're going to do is we're going to create a data set where we take our Pandas data frame, stick it into the data set, and declare the KDIMs, the key dimensions, as country and year, because that's what we're going to index by, right? So unlike the other elements we showed you so far, that doesn't have an immediate visual representation because it's abstract. It's so abstract that we have no idea what we're going to look at, right? We could view this in a whole myriad of different ways, and we're going to start thinking about how we can take our data set and work with it to create different visualizations, right? So one of the first things we can do is use that redim.label method we saw earlier. We have these column names of growth and UNIM and year and country, but as we saw earlier, we want to actually have better access labels for things. So let's just label the data set. Let's just give these columns of our data frame a more useful name. So this is what this cell does. It just recreates this data set element, but with the new labels. Okay, so in the text here, what we're going to talk about is a special thing called a to, where you convert from a data set to the concrete representation that you want for it. This thing has 4 main arguments, and in the text we see, first thing you take is what you want to convert to. Do I want to go to areas? Do I want to go to curves? Do I want to go to scatter? What do I want to take my data set, and what do I want to map it to? Of course, you then need to decide, out of all these columns that my data set have, you might have hundreds of columns. Which of these columns are going to be the dimensions of the element that I've picked? So I've picked a scatter. What do I want my x and y to be for that scatter? Right. Then you have dependent variables to display, which is the value dimensions. And finally, you have a group by. And you'll see all of this. This is all pretty abstract, but you'll see a couple of examples of all this at work right now. So here's a concrete example of what I just said. Let's take our data set, which is economic data, and let's work with curves. We're going to use curves and not scatters. We could have used scatter if we wanted, but let's just say it's time series. There's no reason that you shouldn't connect all the dots and say it's a continuous function, right? Let's make our independent variable the year. So this is the independent variable. This is the kdim. Let's make our dependent variable the unemployment rate. So we use our macro data set, the to method, the element we want to go to, the year as the independent variable, the unemployment as the dependent variable, which will be essentially the y-axis, and group by country. Now the group by country is what's going to be probably the most interesting thing here. So yeah, I'll just actually run it and just show you. This is what we've got. Someone's phone? Okay. What we have here is curves, which is what we requested, with unemployment on the y-axis and the year on the x-axis, just as we said in our command above. And the group by country takes it and gives us this dimension as what we can select from. We can select the country with a drop-down. That's what the group by country does. So now we can easily just skim through all the different countries and see how the unemployment rates changed over this time period. Right? So let's just do something slightly different. So we just saw that with curve. Let's think about a data set. How else might you want to represent your economic data? Well, a thing that you often do with economic data is bar charts. So let's use bar charts and use the bars element. Right? Exactly the same thing, where now what we're going to do is we're going to supply h3.bars to our to thing. And you don't need to worry too much about the sort country. It's just going to keep things sorted. And if we run that, okay, the sort isn't quite doing what I expected it to. But the key point is we now have our bars. And because we've grouped by the year, that is what the slider corresponds to. So here the group by was the country. You've got a drop-down. So it works with categorical data. You don't always have to have sliders. You can have drop-down menus. Here we did it with group by year, which means we can scrub through the year, and we have a bar chart that animates to show you all the different unemployment rates for all the different countries. And we have the countries along the x-axis this time. So we've just remapped things, yeah? Right, this line here. So this is the cell magic. So you see the 2% signs, and that means it's going to apply to this visualization. Right. Right. So here you have a handle on something called bars. This bars is going to have those settings. If you make a new bars, they're going to have the default settings. Right. Yes. GIFs is something that we could have shown you, but you need ImageMagick for that. So as long as you have ImageMagick installed, you can switch to the GIF format, and you can make GIFs, put them on your website. It's something that we had very early on in HoloViews. We just didn't want to show it because you need a few more dependencies. You need ImageMagick to be installed. Oh, it's free. You just need to get that right. And then yeah. We also have MP4, so you can actually have video output, but then you need AVConv. So there's GIF, there's the HTML sliders you've seen, and then there's a video. Those are the main 3 things that you can actually output to. Yep. Exactly, exactly. So when you have a numeric type and you have a range, so the best thing to say is simply that here we had strings, and they're clearly categorical, right? So your countries are distinct and discrete. There's no continuity between two countries. They're different categories of things. So because it's categorical, that's why you get a drop-down menu we can select from. But if you have numeric data that makes sense for that and it's continuous, you can have the slider. That's how that works. Okay, so hopefully we're okay on time. So we actually have an exercise now where we talked about using 2 to map to a particular element, and we just think about the dimensions that we want to use. We want to map our k-dims and v-dims and the group by. So in this little exercise, it just asks you to try and use the macro.to method to do something a little bit different. Yeah, I think I'm actually looking at that right now. So Philip did send me his solutions. I just want to see what I'm doing and comparing it to what he suggested we do. I'm just thinking that that might have been a bit confusing, but I do have the solution here. So it's yes. So the instructions say the VDIMs are year and country. I think that looks like it got it the wrong way around. So the instructions are indeed the wrong way around. Yes, that makes a lot more sense. If you think about it, again, sometimes you have this very abstract, high-dimensional data. You do need to think a little bit about how you want to map it into something that you can actually see. And yes, those instructions were wrong. The VDIM, the thing that you're plotting is the growth, and that's the value. So that is the VDIM, and the things that you want on the axes of your heat map are the year and the country. So sorry about that. That was not correct. So that was probably quite a challenging exercise. I thought so. but I do have the solution. So this is what it looks like. And the thing is, sometimes you do need a little bit of massaging to get things in the way you want. But when you're working from this abstract data, you need to think very carefully about what you need to do to make it actually render correctly. And here, again, the basic thing is actually quite straightforward, which is where you use heat map, which is what the instructions say. Kdims and vdims were wrong in the instructions, but they were just swaps. Year is the x, country is the y, and vdims is the growth. So that's the basic thing you need to know. And the plot options are there to make sure that things can be displayed nicely, because sometimes without them you'd have a few issues. Actually, just have a look at what it looks like. Yeah, it's kind of compressed, but it's still recognizable as a heat map. It just needs a little bit of tweaking. So here, what we've done now is we went from a curve with a drop down. We went to a bars, which you had a slider to scrub through the year, and to a completely different representation, which is a heat map. And this is all starting from this data set element that we created. So let's look at displaying distributions. What we have is what we call a box whisker element, and it's one of the statistical elements that we have. We're actually planning on expanding on the set of statistical elements quite a bit. If everyone's familiar with Seaborn, we're going to try and cover as much of that as we can. There's violin plots, you do all sorts of things in Seaborn, and we hope to have those as elements soon. But we do already have box whisker. So what we're going to do now is we're going to set group by to be an empty list. And we're going to convert to box whisker. And again, these are the kdims and vdims, country and growth. And you set the group by to be an empty list to stop it from trying to group by over the remaining dimensions. So if you didn't do that, you get this, right? It's trying to group by the year. And for a given year, the GDP growth is one value you've got. That's why you have all these flat box whisker plots, because you don't have any data. You only got one sample point. You're making a box whisker from a single sample. It's just a flat line. So you don't want the slider in this case. You want to collapse down across it, which is why you can say do not group by anything, so that you actually have enough samples in each bin for all the different countries that you can actually see a box whisker distribution for the GDP growth. And that will be over all time. So this is all the time values that we have in our data set. Okay? Yeah. That's correct, yeah.
But if we had like other dimensions.
Yeah, you'd have lots of sliders. It'd be grouping by everything it can. So it tries to, basically everything you've not specified, it tries to make it available to you somehow, and it's normally through sliders, you see. And in this case, it was the wrong behavior. You don't want a slider. You want to collapse all those measurements into these box whisker elements. And that's why you say don't group by anything. Okay. So now it asks you to display the distribution of the GDP growth by year. Right. That seems to be just what we did. So I'm going to see what. Okay, it looks like, is that the same thing? Oh, no, that is the same thing. Oh no, it's year and growth, I see. So I'm not reading things carefully enough. Yes, you're basically making the year, the kdim, and the growth, the vdim. You can't put things above cell magics. And that's the solution. So again, you have to read quite carefully and think exactly what's being asked of you. But here we want the year along the x-axis, and that's the key dimension. And we want the growth along the y-axis. So here's the result. And we can see what we're collapsing by over now is the countries, right? This is showing you, for all the countries that we have data for, what was the distribution of GDP growth over time. Right. Okay? Right. So the group. So if you don't specify this, what happens is HoloViews is always trying to show as much data as it can to you, and it doesn't always know exactly how you want to arrange your data, like how you want to present it. So if you don't do that, what it's doing is it's turning those countries into a drop-down menu, right? And then you only have one sample for each country. Each country for a particular year has one value, and that's not going to make a box whisker plot work, right? What you want to do is you want to tell it, don't create this drop-down. You don't want to group by anything, so that each box whisker has a whole ton of samples for all the countries. Hopefully that makes some sense. Yeah. Right. That's a good question. I think I suspect that the way it works is that we have a very standard definition of what a box whisker plot means, right? And that's what we're using. But we're going to expand on the statistical elements, as I said, and hopefully we'll give more options for changing what exactly you're plotting for these things. Okay. Okay. So we talked about overlay and layout and these different methods that you can use to take a container and turn it to a different container. That's where we introduced it, where you could take a hollow map and make it into an overlay and so on. You can do the same thing with a data set. So here, we're going to facet. Right. What we've done is we've taken, we decided that we want to have this abstract data, which is in our data set, and we want to make it into a scatter plot. So we tell it the element we want is scatter. For each scatter, we want the year along the x-axis, the kdim. We have two value dimensions, and that's why you have colors, the point sizes. You have the unemployment rate, which is the y-axis, and that's what you can see along here, and the growth has become the size of the point, and I'll explain that in a second. Right. So I'll try and, right, so if you don't do the overlay, you get a drop-down menu, but you don't want it to be a drop-down. You want to collapse all those drop-down entries into one thing. So you want to take that drop-down, turn it into an overlay. Right? So this is like viewing all the entries of the drop-down at once. Hopefully that's clear. And then the VLabel is nothing special. The thing that makes the growth value dimension into the size of the point is this plot option up here. It's called size index. You're saying that this column, or this dimension, is going to be mapped to the size of the points. And that's done with the plot option. So this is what this little bit here, size index growth is. So right, let's just check the exercise before I try something. So, okay. So we have other data columns in this data set. One was to do with trade. You could essentially say the size index is the trade metric, and you make sure that the trade metric's available as a value dimension, and you can make that the size of the point instead. So again, you just pick which columns you want to map to what. Okay, so the exercise is to facet it, where instead of making an overlay, we make a grid. So you can have a go at that. Though I think I'll peek at Philip's proposed solution myself. But it should be, actually, I'll try it myself and then solve the solution if necessary. Okay, right. Yes. I think you need to do. Oops. One thing I should also mention about everything you're seeing today is we've recently redone the website for HoloViews. There's a lot more user guide material, and you'll be able to catch up on any particular thing that's confusing you, hopefully in the user guide, which we've been working on. And one thing that you might notice about HoloViews is sometimes there's a line that will do everything you want, but you have to think quite carefully about what that line should be. So it's very succinct in that way, but you need to be sure about what you're doing. And I guess that could be a bit of a barrier to really getting it. But for basic things, you can use HoloViews quite easily. It's just data sets, overlays, understanding these concepts. Once you're really good at it, you can do amazing things really quickly, I have to say. So this is the solution proposed by Philip. Well, what he's done is he actually selected only a subset of countries, right? Because we want to make a grid and we're going to lay it out in two-dimensional space, if you put all the countries there, it could be huge. So he's just selected Italy, France, Sweden, Netherlands, which explains the first part of this. So we run that, you just get a data set which has been restricted in its data to just those countries. So you had the whole set of countries in that data set. Now we just got it for these 4 countries, right? So it's kind of like a select operation. Well, it's called select. So. Then we convert it to an area, which is what was suggested, where the cadem is the year and the unemployment is the y-axis. So again, that's exactly what we have. Each one of these things is year. So each single plot is got a x-axis over year. So these are trends. You're seeing 4 trends for 4 countries, right? And then finally, so let's see what happens if you don't have grid. You got the drop-down. So drop-downs can be mapped into overlays, mapped into grids, and so on. So hopefully that makes sense. You get rid of that dimension, which is in the drop-down, and make it something that's spatial. Lay it out in X. Okay. Right. Okay, so we will make the solutions to all the exercise available afterwards. We'll get that out to you. So hopefully you'll be able to see what the requested thing was and see how we actually solved it. And then hopefully things will make sense to you. So this was about faceting. We've taken this data and we've laid it out in a whole bunch of different ways, right? Starting from an abstract data frame. Curves, bars, heat map, box whiskers, and a grid of curves, right? So you really can think of all the different ways that your data might be expressed and turn it into a visual format. Now we're going to move on to aggregating. Yeah? Sorry? Yeah. A single stack plot. Yes, so area has a, I'll just say that there's a class method on area called stack, which basically lets you do stack plots, where you have areas on top of each other and you have different colors for each area. And then you can be cumulative. So you can have a cumulative type plot, or there's different ways of stacking areas. So maybe come back to me and I'll show you that. So we're going to talk about aggregating. So what we've done is we just visualize the data as it is. We put it into the format of elements, but we haven't really done any statistical operations, any computation on these elements before displaying them. And of course, there's also statistical measures you might want to do, standard deviation, means, whatnot, right? So there's an aggregate method, which lets you collapse dimensions using functions which let you compute things like standard deviations and means and so on. So in this case, we've taken our macro data set, we've got the aggregate method, where we're going to work on the year. I'm going to take the mean, right, over the year, and the spread function, which is going to be the standard deviation, right? So this is just to show you what ag is. This is another data set. But notice that you now have trade SD, right? You have unum SD. So it's actually computed some standard deviations over your data set, right? And these columns now become available for you to use in plotting. So if we just do a h3.curve over the aggregate, this is going to be the mean, right? That's the center of all these points. And that's because we did function as np.mean. So we've actually computed the mean and the standard deviation for all the columns. Now what we can do is use the error bars element to actually plot the standard deviation part of it, right? Again, here's the cadem, and growth STD are the value dimensions. So one of those becomes the position of your error bar, and the growth SD is the spread of the error bar. So it's showing you the spread as a standard deviation. Right. So again, it's just an overlay of a curve and error bar. So that's just a sort of typical statistical plot you might have. Okay. So nearly on time for this one, which is good. Right. Here's another example, and you can immediately see that we're not happy with those labels. So let's just set the X rotation. Sorry, this is for bars. Right. So this is just another example of aggregate at work, where we've aggregated over country, and we've done the mean and the spread function, except this time we've used the the stats, SciPy stats module to get the to use that version of the standard error for the mean. Right. So the key point here is that there's two key points to make from this. Firstly, that your data set is something that you can put in this completely abstract space called a data set element, and then you can think about what I want to convert it to. And you think about how those dimensions of your data map to sliders, map to the key dimension, the value dimension of your element, either the x-axis and the y-axis, how you might want to group by things, how you might not want to group by things, right? And finally, how you can then decide to do some statistics. Start accumulating means, standard deviations, supply your own function, and collapse these dimensions into statistical entities that you can then plot. And here we've done it with error bars, and we've also got GDP growth as bars where we've computed the mean and the spread function. So GDP growth. So that was the tabular portion of the tutorial. The next thing is going to show you all the same kind of concepts, but with arrays. We're going to actually have some MRI data, and we're going to look at some X arrays using MRI data. So my stopwatch says it's 30 minutes, so I think that's moving on to the next one. Though I will probably ask for some questions. Is there any particular questions from what you've seen? Yeah. Yeah. Right. Yeah, so there's a whole ton of stuff you could do. Of course, so one thing you saw is that you could supply your own functions, and they're generally ufuncs, numpy ufuncs, and there's a whole bunch of those. The other thing you can do is HoloViews doesn't force you to always use its own API. So if you know how to do something really easily in Pandas, there's no reason that you don't do it in Pandas and then stick it in HoloViews thing, right? You can probably compute some of the statistics you want ahead of time, then stick it in the data set, and then visualize it. So there's flexibility there in how you want to do it. But again, we're trying to improve the statistics support for our elements. Okay? So this is going to be a bit quicker. We'll just spend 20 minutes, not 30 minutes on this, because it's, again, really the same concepts, just shown with a different type of data, but using the data set with X-arrays. So I do realize that from earlier, not everyone has used X-array before, but I'm sure most people have used NumPy. Is that right? Who hasn't used NumPy arrays for things? Okay, nobody. There we go. So X-array is different from NumPy in the fact that this is also labeled data. You actually have what you can call gridded data. You actually have information about the dimensions of your arrays. They can be very high dimensional and so on. So you do have quite a lot of extra power over what NumPy itself would offer. So the beginning is just the same thing again, where we load HoloViews. I don't think we actually use matplotlib. We don't use matplotlib, so you don't need to do that. Right. But what we're going to do in this cell is actually use Xarray, which we can import, and open the data set. So this is an MRI data set, and this is the Xarray representation of that data set. It's a bit different from what the NumPy one would be. It gives you information about dimensions. So you can see there's an X, Y, and Z dimension for this array. And you have coordinates, and they're basically kind of labels for each of the samples in X, Y, and Z. These are basically the same as key dimension, the HoloViews, really. And then the data variables, which would be the value dimension. This is the actual value of your signal, for example, for the MRI. Right? Right. So this is exactly what this little text says. Right? So we have volumetric data. It's 3D. You've got X, Y, and Z. But you could have X, Y, and T, where T is time. So it could be a time series where you're watching something evolve over time. I don't know, satellite imagery over time, something like this. Okay, so just as we did with before, we're going to make a data set. Except this time, instead of passing in a Pandas data frame, we're passing in this X-array. And you can see the representation of data set. Again, it's an abstract thing, so it doesn't have a concrete visual representation yet. But we can see in this representation that you have X, Y, and Z dimensions, which are the key dimensions, and then the MR, which is the MRI response, I guess, as the value dimension. I do realize that perhaps this syntax is slightly confusing because they look a little bit like plot options, and some options with the square brackets and then parentheses, but they're not related at all. It's just how we decided to represent these things. Okay. So this is very repetitive in a sense because we're just doing the same things we saw before, but with a completely different type of data. Now what we're going to do is going to convert to images because we have arrays. Images are the natural thing to do with them. So we're going to say, from our data set of MRI data, let's go to some images, right? And this time, we're going to group by Z. So Z is the slider value, right? So what I can do is I can just scrub through this MRI data. I'm changing the Z value, and I'm looking at the X and Y as an image. So if you imagine this as a holomap, there's like 98 images in here. That would blow up your browser probably. That wouldn't work well. This is why we have this dynamic equals true. And we talked about dynamic map earlier, whereby you can dynamically slice and index things and select them. This is exactly what this is doing. This is making a dynamic map. I can show you that. Right? Which basically lets us sample through Z. And every time I move the slider, what's happening is we're doing an index into the X array at that Z value, displaying it. Right? So this is really, really nice way of scrubbing through things. Okay, so display traversal frontal section. That just means use a different axis to cut through. So instead of cutting through Z, let's just switch things around, and let's group by X or Y, and we'll have a different image to look at. Right. So it does say you should declare the k-dims. So think again about what X and Y should be, and what you want to group by. So. All we're really doing here is permuting the dimensions that we're declaring. So you do need to declare the k-dims and say that what the X and Y are for the image. Right? Oops. Oh, of course. So I've played around a bit. Hopefully you have too. And you've been able to scan through this MRI data through different sections. Okay, so now what we're going to do is we're going to look at, right, we're going to actually, yes, so this is actually a question that I had earlier. What do you do when you have plus between dynamic maps? What happens when you have all these different dimensions and you have dynamic maps and you use plus together to create a layout? What will happen? So here, you just tried permuting X, Y, and Z and scanning through this MRI data in through different planes. What happens if we try doing all three planes, 3 different dynamic maps, and using plus to make a layout? Right? Let's see. Well, we get 3 sliders, 1 for each one of these. So we have 3 dynamic maps. We're slicing in 3 different ways, and we get 3 sliders. And essentially, each slider is a dimension that's left free for you to manipulate. And if, for example, you only have X and Y as dimensions across the things in the layout, that's the only 2 sliders you're going to get. You'll get as many sliders as there are dimensions necessary to specify things. Right. So this is it's quite cool. It's quite a nice way of actually just scanning through some MRI data in a notebook, where you can actually pick a particular position in the brain because you have all 3 slices. So, okay, so this has actually gone really quickly. This notebook. I knew it was going to be shorter. So maybe we can go and do some exercises. The last thing in this notebook, which is again to do with aggregation, like what can happen if we take all our slices in Z and just collapse them into a mean, right? This is the mean signal of the MRI data if you collapse it through Z. And that's what you get. You can actually sort of see a face. So, Okay, go ahead. Yes, I will try that. It's always risky to try anything live, but I'll try to show you that. So we can create a dynamic map this way, right? And we talked about redimensioning things, redim, and I said that redim has a values parameter where you can set values for along the dimension. So let's see, our x value is going from 0 to 255. So fingers crossed, I've not got confused. Redim, what I want to do is set the values. I want to set the values for x. So let's just say instead of 0 to 255, we're going to do 10, 40, 50, 60. 10, 40, 50, 60. There we go. So I hope that answers your question. Yeah. Right? Yes. That's a long-standing feature request. We'd love to have widgets that actually let you type your value that you want, so dragging them. We do have a plan for a widget refactor, but it's going to be a big job. But we do want that. That's something we've had on a wish list for a long, long time. Yes? Yeah. Yes. So Bokeh actually has the ability to have legends which you select things from the legend. So you can just use that directly from Bokeh. That's probably what you'd want to do. So yeah, multi-select tools. There's a whole family of widgets you can imagine adding, and we want to make it more general than what we have right now. But okay. So there's this exercise here where it's essentially asking you to use it's using aggregate instead of reduce. So actually, one thing I should have clarified slightly is we are using a reduce method with mean. So this is collapsing the dimension. We're not. There's a distinction between aggregating and reducing. Reducing is taking a dimension and a computation such as mean to collapse it all down. And you're actually eliminating that dimension. This image no longer has a z, right? There is no more z value. We've got rid of it. We've got rid of it by collapsing all the z values into a mean, right? So this is a subtlety which maybe I didn't quite explain clearly enough. So that's the signature of the aggregate. You can just use the nice signature completion that IPython offers to see what the signature is of this method. Right. Okay, yes. Right, so yep. Yes. Yes. So this is something that I've actually done quite a number of times, where you don't have a nice widget that's in the plot, but you can have a cell above or cell below with a widget, and then you can use that to update the plot. So that's something that's very easy to do, in fact. I think that's probably coming up. Maybe not in that form, but it is quite straightforward. You'll see very clearly where you can put that in. Yeah. Okay. So I think so Philip came up with his notebook, and I can see the point he was trying to make here, which is that aggregate and reduce, they are different ways of expressing, there are different forms of applying an operation. You can reduce, which means collapse it down to z, but you can also aggregate in x and y, right, with a mean. So you're basically taking the mean values of the x and y for for all the z values, and it comes to the same thing. Right? So this is the kind of mirror operations in a way. Which one you want depends on what's most easily expressed. And personally, in this example, reduce is the very intuitive one. I just don't want this dimension. I want to reduce it with the mean and collapse it away. Okay. So I guess, given that we have a little bit more time, any particular questions for the last two tutorials about data sets? Tabular or the gridded? Yep. Right. Something that we do have ways of generating histograms and bidding things. But what it sounds like is you want is a sort of specify the bin edges. Right. I think that's on our wish list right now. It's coming soon, I think, where we'll be able to let you specify the bin edges in various ways, and then you'll be able to aggregate things into bins and generate histograms. I wish Philip was here. I'm sure he'd have a way he could show you right off the bat, but I don't know of an immediate way I can show you right now. Yep. Yes. Yeah. Yeah. Okay, I'll have a look very quickly. So color bar has a few too many arguments. We're trying to clean up this API. Yeah, I know what you're not happy about. It's been bothering us for quite a while, which is the fact that the bokeh toolbar overlaps the color bar when you enable color bar. Yes, that's that's one option. The other one is color bar position. Yeah, that's one thing you can do, or you can move the toolbar. So both are options. That's something that I would like to see fixed, where we can move the toolbar appropriately or readjust the plot appropriately so that we don't have this overlap issue. Okay, so if that's an option. Okay. It's a bit awkward then. Well, maybe we'll find a way of actually injecting CSS or figuring it out to make it more appropriate. Okay, so at least we got the color bar working in a reasonable way. Any other questions? Okay. Size learning for the size plot. Now that I have to admit I don't recall seeing, and it sounds like a really useful thing. Size legends are, yeah. You can do color legends. So if you want to color your points based on a dimension, that's no problem. You just use a color bar basically, because that's just a color map. Size legend. I'm sure Philip would correct me if I'm wrong, but I can't think of it offhand. That would be nice. So you don't think it'd be something we could just have supported right off the bat, then? It's something we'd have to actually construct. Okay, right, I agree. Yeah. Sure, that's kind of difficult. Yeah. Exactly. So I would say actually just file an issue asking for it, because it's something that we need to be aware of. That's something we should be able to offer quite nicely. Okay, I think that will be it. I'll move on to the next tutorial on this, next notebook, unless there's any last questions. Okay. So this is the 30-minute. I think, how am I doing for time? Is it? So let's see. Am I on schedule? Too tired. Okay, I'll just open up this. Okay. Okay, so that's actually fine. That looks like it's going to be fine. Good. Okay. So this is a bit of not a digression, but this is a different thing from what we've just been looking at. We've been looking at data sets and loading all this data into a data set and then exploring it. I'm going to check whether this has just been copy pasted. No, it hasn't. We're actually using matplotlib for something here. Okay. We've talked about, I remember why, yes. I actually wrote this notebook, so unlike the other two. Okay, so dynamic map we have seen before. We decided that we can have a function that returns some elements, and we can actually we can declare some ranges on our sliders, and we can explore that function. So here's something a bit different. It's an abstract thing. It's not real data, it's just an ellipse. It's an ellipse that you can rotate. So you can drag the slider around, rotate your ellipse. Here the ranges are really obvious because it's radians or degrees. You know, it's either 360 degrees or 2 pi radians. What you want to do is you have a function where we create 3 elements, which you can see, a box, which is in blue, an ellipse, which is in red, and then text in the middle, which is in black. First thing I do in this little function is just convert to 2 radians from degrees, because our orientations work in radians. And it's actually nice to look at it in degrees. But in fact, the reason to do that is to show you the little degree symbol is fine, that you can use Unicode. And Unicode works in the slider, Unicode works in the text. Okay, so what we've done is we set the orientation of the box to be pi over 4, so it's at an angle, 45 degrees. Yeah. The ellipse is what takes the orientation value from the slider, so that's the argument that the angle argument that the annotations function takes. And finally, the text takes the angle, turns it into a string, and displays it. Okay, so hopefully that's working for everybody. You can drag the slider around, set the angle. So what's happening here is our function is getting an argument from a slider. Right? What if we could take HoloViews and dynamic maps and supply argument values to our function from anywhere, anything in Python, not just a slider, anything you want. So this is possible using something called the HoloViews stream system, where you can declare some parameters that are to be synced between Python and the plot. Which is updating in JavaScript, at least with Bokeh. Okay, so what we have here is a module in HoloViews called streams and a class called streamer. It's the base class. Now stream classes have parameters. Some of them are fixed and some of them you define. You can define whatever parameters you want this class to have. In this particular example, we want to be able to control the angle of our ellipse. So let's create a new class using stream.define. Now, I guess it might look a little bit weird to people who use Python very idiomatically and you define a class. This is a little bit weird because you're using a method to create a class, but it's actually all fine. You can do that in Python. There's no problem with it. It works quite well, actually. So we create an angle class using stream.define angle, and that's the name of the class, and the parameter of angle equals 0. That's just saying the default value of this angle parameter is 0. So the default, right? So we talked about hv.help earlier. This just shows you that we've created this class, and you can see that down at the bottom you have an angle. And it even shows you the value is 0 by default. So, right. So what can you do with this class? Well, obviously, if you have a class, you can instantiate it. And this is exactly what I'm going to do here. I'm going to say, let's create an instance of angle with angle 45. So forget the default of 0. We're going to set it to 45. Now, what is the point of this object? The point of this object is it can be set, instead of kdims and vdims, you can set the streams parameter of the dynamic map. So the streams is a list of these instances, and here we've passed in an object that has an angle parameter. Okay. The first thing to note is our slider has vanished, right? We're no longer supplying the angle with a slider. We're going to supply the angle with this object that we created, this streams instance. So we said it was going to be a 45-degree angle, and it is exactly a 45-degree angle. Now here's the cool thing. You have a handle on your dynamic map. It has an event method. And in the event method, you can set the parameter to be whatever you want. Right? So we created an angle parameter. Let's set it to 90. Bam. What we've done is we've updated the plot by setting this event value with an angle of 90. It's kind of make sure that you can see it. You know, you're looking at the cell above in terms of the display, and in the cell below, you can set what it's displaying. So you can see that this dmap event is just Python. You can get your values from anywhere. You can make a function of your own, a mathematical thing, whatever you want. As long as you have the handle on the dynamic map and you declare the stream appropriately, you can set the parameter and update it. And of course, this angle parameter matches this angle argument to our callback. And there's a way of remapping that. You aren't restricted to that. You can rename the arguments, but I'm not getting into that in this tutorial. Okay, so this time we're going to try and do some more of the exercises. So try rerunning the cell and setting the initial angle to 15 degrees instead of 45 degrees. Brian, give me a glass of water. Okay, that's pretty trivial. Just change the 4 to the 1 and rerun the cell. So that's just said that the initial angle is 15. Okay, so we did it with the initial value. Now let's actually update this plot with a new angle. Using dmap.event, let's say that we want it to go from 15 degrees, which is what it is now, to 145 degrees. So just try it yourself. It's very easy. Change that one value. Thank you. Okay, so there we go, I ran it, and the plot's been updated. And the last exercise is, what happens if we don't specify an initial angle? Well, the answer is kind of obvious. You're just going to fall back to the default we set, which was 0. So 0. So hopefully everyone's been able to follow through with that. Now here's the reason that we loaded matplotlib in the extension at the top. Does this work with matplotlib? And the answer is yes. So this is the matplotlib version of the thing. It looks different, of course, because it's a different plotting extension. But it's initialized to 0 once again, because that was the default. I can, again, switch back to 45. And if I want to update my, oops, give me a nice warning at least. And if I want to update it to 145 instead of 45, my matplotlib plot is now updated with the new value. So you can actually use this system with matplotlib. Okay, I'll actually let you do this exercise. It's a very simple thing. What we've done is instead of just setting the angle, we've got a function that does the angle and the size. It does the size of the ellipse. You can make the ellipse smaller or bigger. 2 arguments to your function. And just below, I've created a new stream called angle and size, which has 2 parameters. One called angle, again 0 by default, and size, which is 1 by default. Now, just look at the pattern of how we use streams in the dynamic map, and think about how you can create a dynamic map which has 2 parameters that you can then manipulate. Okay, I don't know if have at least some people had to go. Who's been able to do something interesting with this exercise yet? No one? One person? You managed to get it working? Great. Okay, so I'll show you my solution. I've not actually run it yet, but this is what I expect to work. We have this angle and size class. And we're going to make an instance of it, pass it to streams with angle 30 and size 2. I just picked those numbers in my head. That's going to be the streams list. And that's the dynamic map. And of course, I have to make sure I'm using my new function annotations too, which actually takes 2 arguments. Okay, that looks hopeful. It is 30 degrees as requested, and I guess that size equals 2. It doesn't actually show you the size in text. Now, I have a handle on DMAP 2. Let's just use event. Okay, it worked. I can now change both the size and the angle. Okay, so let's, you can start imagining all the sort of things you can do with this. Here's the same thing exactly. This is the first example, so it's just angle. One thing you can do is called the periodic method, where you don't want to do tight loops because you end up queuing lots of things, and then performance won't be good, and you have issues with things being queued, and you have to wait for them to complete. But if you use periodic, you can actually say, I want something to happen every 0.01 seconds. And it will keep running till a timeout, so you can set timeouts so that things don't take longer than you want. And then you have this param function which just says, which has a counter, and it just passes that value. You have a function that returns a dictionary which sets the parameter. So here we're setting the angle, we're returning a dictionary where the angle is just the counter. So you have a counter that goes from 0 to n for however many times you called it, up to 180. You're just returning that counter as the angle. So I hope that's clear. So let's watch what happens. We now have a rotating ellipse, because our periodic loop is going through, updating the angle, and it will do it for as long as 8 seconds, and if it hasn't finished by then, it will stop. Okay? So try a different period value. See what happens if you change it to, let's say, 1 second. It's going to be very slow. You can try pushing it to really fast periods and see what happens if you make it like 0.0001. At some point, it won't be able to keep up, and it will have a speed that will reach a maximum speed. Okay, it's all very simple changing of parameter values. So let's do see how fast it can go. Well, I'm sure that's not taking that. It's much slower than stated. The other exercise was to try and make it do a full rotation. Well, the count is the angle, so let's do 360, and that would be a full rotation. It's going to keep going around. Oh, it might not, because it depends on whether it takes more than 8 seconds or not, right? There we go. So I reached the timeout of 8 seconds. It stops at that angle. But of course, I can increase the timeout to make sure it does complete a full circle. Okay. So yes, small timeout, it stops early. It's not too surprising. Okay, so this is where HoloViews, as we've seen, actually has support for both matplotlib and Bokeh. But this is one feature which is called link streams that is exclusive to Bokeh right now. It could be tied up with any sort of JavaScript client-side cloning library, but we have it for Bokeh and it works really well there. And I can imagine it could be made to work for Plotly, which we also have some very limited support for. We don't really officially support it. But you can make it work with other JavaScript libraries, anything that has events. And Bokeh has an event system now. So these are called link streams. And all that's different is instead of getting our Python value from what we specify in dmap.event, we're going to get that value from JavaScript. We're going to be able to interact directly with our plot, with our mouse or whatever. That's going to supply the values to the stream that updates what we look at. So here's a simple example. We use the crosshair a lot. It's probably not the best use of streams. It's just very simple. It's a very good way of showing you what happens when you have link streams. This time, we're not declaring our own stream. We can't just use stream.define and some arbitrary parameter, because you need to register with Bokeh. It needs to be very specific what it's doing. So what you do is you import from the streams module pointer xy. Pointer xy will follow your pointer and give you the x and y position of your pointer, right? So when you instantiate that with 0, 0, same principle, starts in the origin. But because we have a pointer xy stream, which links into Bokeh, we can now actually hover over our circle and the crosshair follows the pointer. So Bokeh has a crosshair of its own. This is probably not the sort of thing you should really do with crosshairs, but the app you'll see at the end will have a better example of what you can do with this sort of thing. Okay, so that's just following the pointer. So yes, the exercise again quite straightforward. Initialize the crosshair at a different point. Let's just do 0.25. Again, it's so straightforward, I might as well show you. This is where I instantiate the streams, and this is where I'm going to set the initial value. Just do 0.25, 0.25, like that. Okay, so this is actually more interesting. Let's copy this example and make a let's make a point, a big fat point that follows the cursor. So here we had ellipse and v-line and blah blah blah. We don't need any of that. We just need a point. This works. Right. So it's actually quite straightforward. So we're turning this overlay of ellipses and boxes and things, we're just going to turn to points. It's just going to have a single point in it. And that's just going to be the XY value supplied by our stream, which was the pointer XY stream. So not close that. There we go. Got a big fat dot chasing the pointer. Okay. So any questions? Does that make sense? Is there anything particularly? Okay. So what we can see is we have some direct interactivity with our plots. Okay, so this is just a list of some of the link stream classes that HoloViews provides. Pointer X, pointer Y, which is just going to give you just the X, just the Y, and pointer X, which you just used, that gives you both. Single tap, double tap, and tap, which is both single taps and double taps. Bounds. So some of these streams are tied to bokeh tools. So you enable an appropriate bokeh tool, such as a selection tool or a zoom tool, and that will actually change the bounds that are supplied by the bounds X, bounds Y, and bounds XY streams. So that's useful for selecting things. And yeah, I think we've got an example of that. Ranges are very useful for zooming. If you want to have a plot that updates when you zoom in, you want to use a range XY stream so you can dynamically refresh what you're actually looking at, right? You zoom in, you want more detail, you want to pull it in, yeah? Brian might most do. So, okay, we're good for time, 40 minutes, is that right? 5-minute break. Okay, so this is I think it's a pretty cool example. There's more to unpack, so I hope it's kind of using a lot of stuff we've already introduced in the tutorial. So you might have to think about what's going on here. But this is, I think, pretty neat. And it's using the bounds tool. Sorry, actually using selection 1D, which is another thing which I mentioned here. it gives you the selection of glyphs, so you can actually find out which glyphs have been picked. So maybe I'll just talk you through it and before I run the cell so that we have an idea what's going to happen, right? So you can see that we're using the eclipses data set again, which we introduced the solar eclipses, and we're going to pass the dates. So we have date times for our dates of the eclipse event. You can see that we're going to make a scatter. We're going to see that the kdim, the x-axis, is going to be the hour, the local hour. So where noon, the sun's above you. It's got two value dimensions. One's magnitude, and that's going to be the y. We've also added latitude. So we've given it two value dimensions. And why would we do that? Well, we can map that to something else. We've actually mapped it to color index. So the latitude is going to be color bars. We're going to have a color bar for the latitude. So here's the streams bit. We have a little callback where we're returning a text element on top of our scatter, where this index is this selection 1D stream, which basically tells you how many points have been selected, right? Or it tells you the points that have been selected. So if you take the length of that, you're going to have how many eclipses you've selected, right? And that's what you're returning with your text in the overlay. Then we create the dynamic map. We just pass in the streams selection 1D thing. And finally, we're just doing some redim labels, so we're just setting axis labels. So hopefully, you'll be able to have an idea of what to expect based on what I've said. These are all concepts that hopefully have been introduced reasonably well enough that you can follow that. And let's see what it looks like. There we go. So it's a scatter, as we thought. Color barred with a latitude. So the color of the point gives you the latitude. Those are the x and y axes we thought we'd get. And what about the streams? Well, I've got the box select tool here, which is just for the x-axis. I can then select a number of eclipses and see exactly how many eclipses I've selected. And I did that because I returned this text element where I have the length of the index. So I know which points have been indexed if I want to have that information. But I've just counted them and said there's 153 eclipses in that region, right? So it's quite a lot to unpack, but you can see in very few lines of code, we've gone from really nothing except for loading the extension, I guess, to customizing what it looks like, loading the data with Pandas, creating the elements that we want, setting up the streams, and then gaining interactivity that way. So I think this is something, it's an artificial example, but you can imagine building a real visualization dashboard with a few lines of code that you can then deploy. And that will be something we'll come to in a little bit. Okay. So any particular questions about what I've shown here? So there's quite a lot of plot options, for example, where I've set the color bar title and the position on the bottom for the reason that we saw earlier, where the color bar wasn't in the right place, or it was in an awkward place. And you can see all the plot options where Xbox select is quite important here, because that's what gives us this select tool, which lets us, which gives us the stream values for what we've selected. Sorry. There we go. Any questions? Sorry? Yes. This one or the one before? Okay, so it's a good point, because what we can do is condense everything about streams into one very simple example. What's happening here is we've imported from HoloViews streams.pointerxy. And this is a class that will help you track the pointer in Bokeh, right? So we initialize it with a position of x and y of 0.25. So you can actually see it is 0.25. You look at the axis labels, it's correct, right? And we create an instance of this thing. This is an instance. So you can actually do this too. Pointer x, pointer.y. These are attributes that this pointer has. What's going to happen is when we move our mouse over the plot in Bokeh, it's going to update these values, right? And then these values are going to be passed to this function, crosshair. Well, it's no longer a crosshair, I should call it points, or point, right? So this thing takes the x and y value that's passed and makes a point at that position. And that position is taken from the stream, which is tracking the pointer. So then as long as I pass in my pointer instance to the streams list, then HoloViews will pass that information about the pointer position to point, get the points object, and display it. And that's why the pointer now follows the cursor. Hope that makes a bit more sense. Oh, color equals red doesn't work, and you're using bokeh? Okay, should have the break, yeah. So let's take the break and we can look at that. Any other questions just before the break? We have 5 minutes and then finish off. Yep. Okay. I think a lot of color maps have like reversed versions of themselves. So you just use like there's a red to blue and there's a blue to red, and there's like a normally you can just like add R at the bottom of the color map and it flips the color map. Yep. Yep. Yes, it breaks. I knew someone would spot that, and it is a bug. It does break. It's unfortunate. This is an issue we have, and we're working on it. It doesn't always break. We're going to have to find out why this kind of example breaks. It doesn't. It's not all. I'm fairly sure that there's no problem with this one. I might be wrong. Something happened. It still works. I think the axes vanished, right? Hmm. Yep. Okay. Okay. So the box selection breaks, does it? Okay. So yes, we are aware of that issue, and it's not supposed to do that. It will be fine once we fix that bug. Just be able to reset. Okay. Should we take 5 minutes off? 5-minute break. Okay. I'd like to continue with the last two notebooks. What I hope to show you is how we can really work with really huge data. Okay, just wait for a few more people. How many people here have heard of data shader? Okay. Good number, a reasonable number. So data shader is essentially comes down to a really fast rasterizer. And what it lets you do is view huge data sets essentially interactively. So with data shader, you can think about, gigabytes of data, tens of gigabytes of data, even bigger, and anything that fits in your memory, you can start to visualize once you have data shader. And really the way it does that is it takes a lot of data, and instead of trying to plot everything the way Label Bokeh does, where you're trying to actually make points everywhere, or if you're doing scatter and so on, it rasterizes it. It turns what you want to visualize into pixels. And essentially, each little pixel that you're visualizing is a bin. You're aggregating your data, and you're creating a visualization as an array. So what it lets you do is it lets you take data sets that just wouldn't be plausible to actually visualize normally, and to start looking at them, and in fact, starting to look at them interactively. So in this notebook, I'm going to talk about how HoloViews exposes some of the functionality of data shader, and I hope, who doesn't have the taxi data set, the CSV file? I do have a USB stick, and I had meant to pass it around. Who does have the taxi data set? Okay, good. So I'm happy with that. Good. So what I'm going to talk a bit about first is a little bit how data shader works, and I've kind of already summarized that briefly. You have your data, and what's going to happen is we're going to put this in HoloViews element. And this time, the data is going to be big, and it's not something you just want to visualize with HoloViews, because you're going to break your browser, you're going to break Bokeh, you're going to break everything. You'll run out of memory. It's just not good. That's how big the data is going to be. What you want to do instead is pass your element with this huge data set to data shader. And what data shader is going to do, it's going to take that data, it's going to do some aggregation transforms where it bins things really fast using number. So it knows in this pixel, and it can be at the resolution of your screen, in this pixel there's this much weight, there's this much data here in this pixel, and then it turns it into an image or an RGB element, so it can be color mapped, or it can just be an image where you just have a single color map instead of, sorry, I confused that, but you can either be color mapped, where you just have a single value which maps to a color map, or you can actually have RGB values, which lets you do things like dynamically coloring things in ways which would not be normally possible. And then what happens is data shader then takes this data and passes it back to HoloViews to visualize it as an image. So we already see an image, and now what's going to happen is our images are going to actually be reflecting huge amounts of data instead of small arrays. Okay, so here's a few bullet points about when to use data shader and when not to. When not to do it is if you've got few points. If you only have a few points, you're wasting your time using data shader. Just plot it. You should be fine. If you actually care about every single data point that you're looking at, then obviously don't use data shader. You can just plot it, because if it's enough that you can see yourself, you don't have that much data. And if you want interactive tools that that Bokeh offers, you lose some of that when you use data shader. But if you do have large data, and you care about the distribution of the data more than the actual individual points, you have so much data that a single sample is kind of meaningless, then maybe you want to use data shader. So this is all very similar to what we've used before. It does import a few more new things. One is data frame, which we'll be using to get some good performance out of the data frames. And also a project which is based off HoloViews called GeoViews. And this is used to do geographic stuff. So if you have a projection where you care about the shape of the Earth and the curvature of the Earth, and you want to use Mercator or Plat Carré or some of the different projections that you might have for maps, you should use GeoViews. And it's really designed for geographical data, especially on large scales. Okay, and then the final thing are these operations that we're going to use. And they're imported from HoloViews Operations Data Shader. And these things give you access to data shader from HoloViews. So let's actually start by looking at how big this data set is. It uses CounterPy. I can't quite remember. Philip is behind GeoViews. I don't think we use base map. I think we're using CounterPy for most things. So let's have a look at how large this data set is. Okay. Right, so it's 1.4 gigs, which is actually pretty moderate for data shader standards. But you still wouldn't want to plot that with just a regular bokeh plot. So here in the first line, we're just loading the data frame, except we're using a Dask data frame to do it. That gives us a few benefits in terms of performance and so on. And it also lets you, for example, process things in sort of chunks, which you wouldn't be able to do otherwise. Right, so I'm just going to run this, and we're going to have a look at how many rows and columns that data frame has. Of course, it's going to take a little while just to load the data. So that's filling up 1.4 gigs of my RAM, at least, if not more. Then we'll see how big this is. Note that we're using past dates, so actually it's going to take a little bit longer also because you're going to go through this data frame and you're going to turn all those things into date times and actually get proper date objects. So here we go. We have, I think that's 10,679,307 rows. I think I got that right. So it's a lot of rows, and you wouldn't want to plot all those points at once. And here are our columns. So this is taxi data. Essentially, it's taken from Manhattan, so it's in New York City, where you have lots of information about taxi drop-offs, how much people tipped, the length of the fare. You can see these columns here, how much they paid in total, and so on. And of course, locations, where they got picked up from and where they got dropped off. Okay, so this is, that was instant. That was absolutely instant. Creating the HoloViews object was instant simply because it's a wrapper around your data. And your data's just been loaded. You had to wait for that. But to actually create the points object, no time at all. Because all you're doing is you're wrapping in a HoloViews object. Now you have to be really careful here. If you do this and run that, you'll probably break your notebook. Because you're going to ask HoloViews to display 10 million points. You don't want to do that. What you want to do is use data shader instead. So we imported this operation called data shade, right? And what we do is we pass that the points, so that data shader goes, okay, I'll rasterize this data, send it back to you as an RGB image, right? There we go. So you can see Manhattan. And this is Manhattan as seen by taxi pickups only, right? Taxi drop-offs only. So this is where people have been dropped off. Each little point is in there, and you can actually see the outline of Manhattan quite nicely. Now, the cool thing is, this is all hooked into the stream system that you were introduced in the last notebook. So I talked about this range stream, and that lets you zoom in, and it dynamically fills in all the data to the resolution it can. So if you zoom out, you get a nice global overview. And if you zoom in, it redoes the aggregation and all this binning that data shader does really quickly to see the data at that level of detail. Right. So one thing which is, you might notice that the axes have not great names, and they've also got these weird, very large numbers. That's to do with the projection. If you go to the HoloViews website, if you're worried about that, there is an example that actually turns into latitude and longitude in the gallery. It's based on the same thing. So this is just the GIF, and this is what happens if you actually turn those values into latitude and longitude. Right? And that's kind of similar to what we're going to be working towards now. So that's an introduction to the operation. And this is really great for viewing, I don't know, if you have huge data sets, this is going to be really helpful. So as I said, this is using the stream system. It's using two streams. Plot size, which lets data shader operation know approximately how big you've made the plot in your browser. And that's useful to set sampling values and so on. And also this range stream, which tells you how far you've zoomed in. So it knows if you're zoomed right in to a tiny bit of Manhattan or you zoomed all the way out, then it can render things appropriately. So here's an exercise where we're going to use a different color map. So one of the color maps we've got in DataShade is called Inferno. And what we're going to do is we're going to plot the pickup locations instead of the drop-off locations. And again, be careful not to display your points directly, or else your browser will break. And we're hoping that we'll get around this. So we'll have some mechanism by which if the data is really huge, we don't just break your browser. We'll say we can't render this, just use DataShade instead. Okay, so that's the first exercise. Okay, and I suppose one thing you should know is that the data shade operation has a color map or CMap argument. And that's how you're going to specify this Inferno. I don't think that was obvious otherwise. It does kind of say, actually. So there we go. It's not a style option. Okay, so the key point here is that the points, which we had before, as we saw much earlier on, you can put a data frame into a points object, and you can select the columns of the data frame that you want to be your X and your Y. That was right at the first notebook. What we're doing is we're selecting the columns of the data frame which are corresponding to either drop-offs or pickups. So earlier on we saw drop-offs, and now for this exercise we're going to use pickups. What we're saying is this giant data frame, where we're going to get the pickup X and the pickup Y, make this huge point object that we don't want to look at directly, but that we can pass the data shade operation and give it this color map Inferno. Right. So now we can zoom in and do all the same things again, but with a different color map, and we're looking at different data. We're looking at a different column of this giant data frame. Okay, so now I mentioned GeoViews earlier. One of the things GeoViews offers is a way of loading map tile sources. So actual map data, you'll see in a second, whereby we're actually using a combination of a bokeh model for a tile source and what GeoViews offers as an element, which is a WMTS, which is a tile source. I guess this might make more sense to people who do a lot of geographical stuff. Might not make sense so much to everybody, but you'll see what it means. You'll be familiar with it. So there we go. It's a tile source. You can actually see some satellite data. Because we've overlaid the data shade operation and the output of it, which is this dynamic map, over our tile source, when we zoom in, right, we can see that both the tile source and the data shaded data is coming into, it's loading in, right? And of course, at some point, if you zoom in far enough, you can see the individual points at which taxi drop-offs happen or taxi pickups happen, right? The main thing that the bokeh model here was used for was to take the URL, which here is ArcGIS Online, so it's a remote URL, and you pass that to GeoViews to make this thing that you can overlay. Okay, so this is a very similar exercise. We're just switching the URL from the ArcGIS thing to a Wikimedia server. I'm not actually trying it myself, so I'll find out what it looks like. Copy and paste. Okay, I hadn't actually seen this before. Okay, so this is the one from Wikimedia. Let's see if it also lets you. Okay, That's nice. It also does the zooming in and giving you more levels of detail as you zoom in. Yep. Yes, they're in the same projection, and you have to be a little bit careful about things like that. But GeoViews has an operation that lets you do reprojection. So if you're on a different projection, you can switch to a different one. And it also actually has a projection parameter where you can specify the projection as a plot option, essentially. Right now, it's all implicit. I can't remember what it is. It's Metadata or something, what it is by default. But you can use different projections, and that's actually something that GeoViews is kind of tailored towards, is it's there to help you with projection issues like that. Okay. So we talked a little bit about aggregation before, but now we're going to talk about it in the context of data shader. So data shader, as I said, is a rasterizer. It's binning data really quickly. And you can bin things in different ways. You can take the mean or the count or other statistics is what maybe what you're actually reflecting in what's being data shaded. So here we're going to do, we're going to look at the total amount, right? We're going to actually look at the total amount up to, I guess it's $1,000, right? So these are really expensive taxi rides in Manhattan, where you go from, paying nothing at all to $1,000. We've selected that as the total amount that the person paid, right? That's just a selection. We've selected it on the points. Okay. So I have to admit, I'm not entirely sure about the line about persist. I think Philip would have been able to tell you what that's about. But essentially, what's important here is that we've specified an aggregator. This is another argument to the data shade operation, where what we're going to say is we're going to take the mean of the total amount. So this is, again, a column of the data frame that tells you how much people paid for their taxi rides. Okay. So it looks different, as you'd expect. And because we switched our tile source to the Wikimedia one, it's still that one. We could switch back to the ArcGIS, I think. So I just hit reset there, and it zoomed in. I can't quite tell you why. But actually, that's a reason. That's probably the data range, to be honest. That's probably the extent of the taxi data. So it's going to go from the most north pickup to the most south pickup in the taxi data. And of course, you can zoom out, way out, probably. Right. So that's what it snapped to. It snapped to that area where the taxi data is when you reset. That's what I think is happening here. Yeah. Okay. So this exercise is about using different aggregators. I think I'll skip it because I think people want to see how to deploy things as Bokeh apps. This is quite a straightforward thing where you just change the type of aggregation. And I think it'd be more informative to get onto the next notebook and finish off the tutorial with a Bokeh app example. Okay. Right, so all the kind of techniques that we talked about in HoloViews earlier, group by, having sliders, all this kind of stuff still works with this operation. So here we're using the aggregate operation from data shader operations or operation.data shader. And it gives us a dynamic map. That's what you get. And what you can do is we saw with dynamic map that you can do group by. You can change the type. You can select different dimensions to map to different things. And when you use group by, that becomes the slider. So what we have here is really quite neat, I think. You can zoom in. You can fill in all your data as you zoom in. But it's also time series data. So you can actually scrub across the hour and see, the pickups or drop-offs in this case in Manhattan for some variable. I think this is okay. It's drop-offs. Yeah. So these are the drop-offs in Manhattan at hour 0. You can go to noon. You can scrub through and see how the patterns of flows of taxi drop-offs changes over the day. Okay. So we will have time to talk about deploying as a Bokeh server dashboard, and we've got about 20 minutes, because this is the last cell, where what we're showing here is a few tricks that you can use with HoloViews to make things give you a bit more information. This is a trick. It's quite a clever little trick, where what we've done is we've made a quad mesh, which is invisible. So there's actually a raster, if you like, over this whole image that you can't see, that has the data that you can reveal with a hover, right? So can you see the little blue square there, right? That's the hover line alpha. And that's basically showing you where you're hovering, and that's a little block where you've collected some data and you've revealed that data with the hover tool, right? The actual quad mesh itself is invisible, but the data it contains is now visible by hovering, or wherever you hover, right? It's a bit more of an advanced example. I don't think we need to worry too much about it. But the key point is you can now start revealing more data from Data Shader than you could otherwise. Because Data Shader gives you RGB images. And RGB images don't have these tools naturally. You need to actually enable these bokeh tools, and they have to work with the correct glyphs. And unless but with HoloViews, you can do tricks like this to start revealing actual values when you hover, right? And then of course, you can still zoom in, see all the data come in, and actually have some information about the values at these different positions through scrolling. And again, just to reiterate, this is all working through streams. Based on my zoom level, that's how it actually knows to update and so on. Okay, so I realize that some of this has not been explained. I think you can think of this example as more of a proof of what you can do, and if you come to that documentation, we'll have explanations of exactly what's going on here. I don't think we have enough time to unpack this exactly. But we will... Yeah. That could be GPS errors. It could be... Well, that definitely... Yeah. Well, you can see that it is following the streets, right? So that is kind of odd. It must be GPS noise. Yeah. Police would be interested in this. Okay, so we're going to actually see now for the final notebook, which we have about 15 minutes for, so I might have to go through it fairly quickly, how to deploy this sort of thing as a bokeh app with Bokeh Server. Okay, so I'm going to shut down this notebook because it's using up a lot of RAM. I'm going to clear out all the cells. Actually, you don't need to really worry about this because it's rasterized, so actually the amount of data in the notebook isn't that high. It's the amount of data in the RAM in terms of the data frame that's taking up space. Okay, so let's go to the last notebook. Here we're going to actually see some actual Python code outside the notebook. And it's going to be kind of difficult to try and do those exercises live. So what I'll do first, at least, is go through these and show you how you can deploy as Bokeh apps, and then hopefully we'll have some time to do some of the exercises before the end of the tutorial. Okay, so this is an example of a really simple Bokeh app as declared with HoloViews, right? Most of the concepts are what we've seen already. You create elements, you load data from Pandas, you put it into points, you select your key dimensions, use the data shader operation that we talked about. All that stuff has been covered. We didn't talk too much about the ops method here, but I did mention it, and we said that it would clear the style settings. It's another way of setting options, and it's a way that works outside the notebook, so you don't need the magics. So what is different? This stuff, part 2, is actually everything we've seen already. What's new is part 1 and part 3. Part 1 is where we use HV.render, and this is digging a little bit into how HoloViews works, where we pick the renderer for bokeh. There's one for matplotlib if you're using matplotlib, but what we're going to do is we're going to pick this class called the renderer, which is handling everything about bokeh as far as HoloViews is concerned. We're going to grab it. So now we have a bokeh renderer. Now what we're going to do with this? Well, all we need to do is pass our HoloViews object to this server doc method of the renderer, right? And that gives you what's called a bokeh document. And once you've got the bokeh document at the end of your script, you can give it a title, and it's a bokeh app. I'm sure Brian will interject if I say anything wrong. Okay, so this is a very simple example. And the only thing that really changed from everything we've done is this first line to get the renderer, and this last bit where we just got 2 lines where we set the title and get the bokeh document. So yeah, it says that in the instructions. Steps 1 and 3 are boilerplate. You don't need to worry too much about them. Okay, so let's deploy this with Bokeh Server. Right. So the script already exists in the repository. So you can use your own terminal as long as you activate the environment, make sure you're in the right place. But you can just use the terminal supplied by the notebook. And let's run it. Okay, it'll take a little while because we have this big data set, which is again, I think, the taxi data set. There we go. There's Manhattan. And this is something that you can deploy to a server. It can be something that other people access. And Bokeh Server is a really good way if you're worried about security and you want a really robust way of serving visualizations. Bokeh Server is a really good way to go. And all the cool things that you've seen with streams and data shader and all this stuff in HoloViews is now available as a Bokeh app with just, basically 3 lines of boilerplate code. And this is something that if you set up, you can share it to different people. And I believe Bokeh Server will handle multiple connections correctly and so on and so forth. So it's a pretty robust way of deploying a dashboard. Okay, so that's first server example. Let's jump back here. Okay, so as I said, I'll skip the exercises just to make sure that everything's done and have time for questions and maybe to do the exercise as well. Okay, so there's other ways of actually deploying or looking at Bokeh apps in the notebook with HoloViews. So let's just overrun this a little bit. So that warning is in Odo, so I can't really silence it properly. You probably see that as well. I guess that will be fixed the next time we have a release. So again, we're loading this taxi data set. We're passing the dates. We've picked some columns that we're going to use from a data frame. This is actually all the same stuff that you saw in the last notebook. Again, we're using Dask data frame for performance, and we've loaded the extension. Now we're going to start setting up some streams. These aren't linked streams. I talked about the ones that use Bokeh and let you interact directly. This is a counter. It's a really simple thing. It literally counts events, right? So it's only got a simple parameter. So here's the stream. And it's got a counter parameter, which starts at 0. And every time you do an event, it'll just increment. So it's nothing very fancy. Points is as usual, but with a big data set, which we want to data shade. A dynamic map, where it's kind of a more complicated expression, where it's doing a 24-hour modulo. So it's, your counter goes to 1,000, but you want it in terms of 24 hours, because that's the date. The data got 24 hours of data. Right, so it's basically doing a select, and it's making sure that your counter doesn't overflow, basically. Okay, so we're going to data shade it, set some options. And this is another way of setting options. It's the ops utility. Again, pure Python doesn't need to use special magic syntax. We've got a tile data source, and let's just have a look at this. So actually, we've grabbed a whole handle on our overlay. We're not going to look at it straight away. We're going to launch it as a Bokeh app. So I know some people have had trouble when we tested this, so I think it works for me, I believe. Hopefully, it'll work for you. You need to make sure that the local host port number matches the notebook server port that you're using. So hopefully, at least a good number of people have that working. Who's got that working? Okay, got at least good. So it's not completely. Who doesn't have it working? Okay, right, so I'll have to look up what's happening there. Okay, but here what's happened is we have the same thing we saw before, a tile source and a data shader. We can do the same thing of zooming in and so on. But what's different about this is we set up this counter stream, and we talked about the periodic utility, and we're just going to bump up the hour. We're going to bump up the hour. We're going to keep doing it, and it's going to do modulo 24, so it's going to loop round. And let's have a look at what that looks like. Okay, you can see the update. So that's showing you the hour of the day, and it's showing you the taxi pickups and drop-offs for this whole data set. I think it's drop-offs. I never remember which one. But anyway, it's one of those columns of the data frame, visualized with data shader on top of this data source. We're going to loop. So it's going to go to 24, and it's going to go back to 0. And that's why you had that modulo. Oh, back to 0, yeah. Right, so I think the default is count. The default aggregator is a count, which would be how many things are happening. Okay, let me have a look. I'll have to go back here. So let's have a look. How is our represented? So this is using relabel, where we could, we just use the counter. We could say pick up, well, it's actually drop off, right? So you can say hour of drop off or something. And then the title would be hour of drop off, so you know it's drop offs, right? Is that the question, or you want to? Counts. Oh, right. That's a really cool suggestion because it's a really good for demos. You say, I'm looking at 1 million points here, or 10 million points or something, and that'd be really cool. So it's something I think we should just put on our to-do list as something that we really want to demo. I don't know how to do that offhand, but that would be really cool. We know that the whole data set is what, 10 million points, right? So if you zoomed out, that's how many. Oh, but by hour, yeah. So data shader can do much bigger. Really, anything that fits in memory can be data shaded more or less. Yeah. Okay. Yes. Yes. Right. That's a very good question, and the answer is yes. There's a bunch of different elements. It doesn't have to be points. You can do paths. That's something that we're working on, so that you can do like huge networks. Like you've got huge connectivity networks, and you want to just data shade it because there's just so many connections. That's something that's being worked on right now. Paths are going to work. There's work that's coming up for spikes, like just spikes. So there's lines and there's points for sure. And I think there's work to be done on other types of glyph or HoloViews element that you could pass in a data shader to data shade. So the answer is yes, probably not every element can do it, but a good number can. Yeah. Yep. Yes, I suspect so. I don't know offhand what the plot option would be for the tile data source. I don't know if it's simply alpha. I don't know if Brian would know. But I'm guessing that what you can do is you can do the .opts thing here, and I can't tell you offhand, but it would be something like alpha equals 0.5, then it'd be, so actually what you want the points to be less opaque, right? Okay, so that's probably also doable, because the output is an RGB image that has alpha channels, so you can actually set the alpha on that. So you could make the taxi data points less opaque, so you could see the street names, yeah. Okay, so the last section of the whole tutorial is combining HoloViews with bokeh models. So bokeh, I don't know how many people have heard of bokeh models or use bokeh at that level. Okay, good number of people. You can actually combine them, so you can actually use HoloViews together with bokeh models. And that's going to be at the last app of the whole tutorial, where we have a slider, which is a bokeh model, I believe, yes. And we're going to use that with the streams to actually work with our plot. So what we're going to do is we're going to create this. We have a plot object, which is from the renderer. So we got the renderer earlier. We get plot, which is this plot instance. And then when you call .state, you basically get, I think it's a bokeh figure. I might be corrected, but it is, .state is a bokeh figure, I believe. And then you can use bokeh layout to put a model, so your slider or your button, together with your plot.state, together to create an actual cohesive dashboard. We've combined some bokeh models with HoloViews objects. So I'm going to actually just show you, and that's the last demo. That's the first, that's the GIF that you saw at the beginning of the whole tutorial. I just hope I'm not running out of memory or something. No, it's fine. Oh, I am actually still running a, yeah, there we go. Okay, bokeh serve. Okay, so this is using all the concepts that were talked about in this tutorial: streams, link streams, of course, HoloViews elements. I guess it doesn't quite show you containers, which, like HoloMap, dynamic map. Oh, it does show you dynamic map because that's the output of the operation. That's the output of the data shading operation, right? So here we go. as I move my cursor left to right, I have this V line, which shows me the cross section I'm taking. It's a little bit thin. It should be a bit thicker than that. Can't really see it. But you can then see a sample of our data along that V line, and that's what we see on the right. So you can see the cross section of our data. We can move our cursor back and forth to see the different distribution. Of course, we can still zoom in, have everything fade in appropriately. Right? And lastly, because we combine the bokeh model of the slider and the button, what we can do is hit play, and there we go. That's all this interaction is now in this little app, whereby you can see the time series over time over 24 hours. You can see the cross section. You can interact with it directly, and you can deploy it as a bokeh app. So I think that concludes the main part of the tutorial. I'm open to questions and things, and maybe people want to do exercises or ask me other questions. That's good. Okay. Any questions? Yeah. I tested it with what, sorry? Raspberry Pi. Oh, okay. I don't know. I think most of these things we're expecting them to be on sort of laptop machines or more powerful servers. I don't know. I've never tried it on a small device like that, but I have no idea how well it could perform. It'd be interesting to find out, I guess. Yeah.
Although it should be mentioned that all these things can also work with mass data frames, so it does actually open up the possibility of out-of-core processing of some larger data sets. But obviously, there's no evidence now on the performance or responsiveness of that.
Okay. Any other questions? Okay. That's great. Thank you very much.